Good morning, everybody. My name is Vishnu Dutt, and I have Dhaval, Rohit, and Prashant with me today. We are into our fourth session of Cisco Certified Network Associate. Today's session, believe me, is going to be really interesting, and the reason is we are going to see the packet walks. Right? We all know now what is a packet, what is a frame, what is a segment. If you do not know, I would highly recommend to watch the videos recording, right? Available on YouTube, available on the website also. You are going to get the access soon. Do not worry about it, right? So today's session, we are going to discuss how to computers talk when they are pretty near. What is the meaning of near? Maybe they are just 50 meters away, right? And we call such network as the local area network, right? And we know if you want to talk, I would say Aman Kumar Singh, please be on mute. Everybody should be on mute for now. Thank you so much. So, as I was mentioning, that if two computers are nearby, or if we have a network which is really network of hosts which are pretty nearby, we call them LAN, local area network, right? And if we have a LAN, we also know that there were people who were developing this network, which is known as Ethernet network, right? We were talking about it. They invented the switch, which only understand MAC address, and we were connecting multiple hosts to the switch so that they can talk. And here is the number one thing which we are going to do today. We will go into every nitty-gritty how these two computers are going to talk with respect to this switch, how this switch is going to behave when it receives a frame. If I say frame, frame is a unit at data link layer. It is as simple as that, right? We discussed about it yesterday. And here are our two characters. Miss Anjali is here, Mr. Rahul is here, and they are talking to each other. That till now we have little bit understanding of TCP/IP. We know how packet traverse from application layer to the physical layer, right? And they were pretty okay with respect to the whatever the knowledge they have gained, right? But they want a complete understanding that what exactly happens when a packet is created, how the packet is created, then how it is going to flow over the switch, right? And that is my agenda of today's session. Point number one, how do computers talk when they are in same network, or basically they are in the same local area network, I would say. We will be introducing one more term today, which is address resolution. What is the meaning of address resolution? If you see anywhere where two addresses are interacting, IP address here in this case, and MAC address, because at the end of the day, the system will be having IP address as well as MAC address. How these two addresses are interacting with each other, we need some protocol to resolve these addresses. What is the meaning of resolution? Do not worry about it. We will be talking about it. Then I will definitely show you today how these packets looks, right? How these packets look in Wireshark. Wireshark is a tool where we can actually capture these packets which are flowing over the wire. Very easy, but we will see that. The another point, the point number 4 of today's session is going to be how do computers talk when they are in different network. Maybe one network is here, the other network is here. Here you have created your own local area network, and here another local area network, and now you want to talk between them. Maybe here you have 255 hosts, here also 255 hosts, and they basically you all know that you need a router to communicate between them. We will be seeing exactly hop by hop basis what exactly happens when two computers which are not in the same network wants to communicate. We will be seeing the packet walk. Okay. Now, we are talking about two LAN which are pretty nearby, and I'm pretty sure that now it doesn't matter whether the computers which are talking, which are in different network, are only 1 mile away or many miles away, or there is a sea between two nations. then how these two computers are going to talk, right? Believe me, there is not much difference. If you understand how two computers talk at the first place inside a common area network or the local area network, then remaining things are going to be just extension of it. So point number one, we are going to spend too much time there, maybe 1 hour, but this is going to be important, right? If you give me next 2 hours or 2.5 hours, I will make sure that these concepts are under your belt. And believe me, I have seen many networking professionals who are into this industry for many years, but they have many doubts, whatever you're going to learn in today's session. So just spend 2 hours, sit and relax, just see this, have a cup of coffee, but try to understand whatever I say. Having said that, let's move to our first board, where I'm going to talk about a few cool things, right? And here you go. So this board is setting the expectations that what you should know before starting this. And we have already spent around 6 to 7 hours in computer networking, and you all know the term switch, you all know the term laptop, routers, network, and so on, right? But what exactly the meaning that how two computers are going to communicate inside a network? So I have drawn this gray cloud. This gray cloud is representing a network, right? And inside this gray cloud, we have two hosts. One is Anjali and another one is Rahul. They are having their laptop. This one is Anjali's laptop. This is Rahul's laptop. We all know about it, right? And I'm saying that this is a network, so it means that it should be having a network number because you all know IP addressing well now, right? So you should understand if I'm saying network and it's a digital computer network, it should be having the network address, and that is what I have written here. 192.168.100.0/24. And what is the meaning of it? The meaning is pretty straightforward. If we have 192.168.100.0/24, we all know for the fact that 24 bits are reserved for the network and 8 bits are reserved for the host part. And if 8 bits are reserved for the host part, we are going to have 256 hosts. Out of them, 2 we cannot use because first address is going to be used as the subnet address, which I have written here. And the last address is actually the broadcast address, the IP broadcast address. The remaining 254, 254 addresses we can use. And that is what I'm using here. For Anjali, I will be using an address which is dot 100. What is the meaning of dot 100? Why I have written only dot 100? And the reason is because you all know this is part of a network which is 192.168.100. So you can straight away say that Anjali's IP address is 192.168.100.100. Similarly, Rahul's IP address is 200.200. The complete IP address, if I say again, it is 192.168.100.200. It is as simple as that, right? So this is all about network, and we are going to talk about that how these two computers are going to talk if they are in same network. They are in same network, right? If I say IP address 192, okay, let me write it here. 192.168.100. Okay, this is not 100, guys, this is 10, right? Or let me correct myself by seeing the next board because I do not want to get confused or to make you confused that which IP address range I am going to use. So I will be using the IP address range 192.168.10 dot something, right? So this network is not 192.168.100.0, it is 10.0, and this host address is 192.168.10.0. So 10.100 is the IP address of Anjali. Rahul's IP address is 192.168.10.200. If I write a mask here, you straight away say you can calculate in your mind and you can say these two hosts are part of the same network, and that is what that is what the first point of today's session is. How these computers are going to talk when they are in same network. And yesterday we discussed In 1973, there were few people who were developing this Ethernet, right? Which is exactly dealing the same problem. And again, TCP/IP model is also in the development parallelly. In TCP/IP model, we have seen the IP address. In Ethernet, we have seen this MAC address, right? And Ethernet guys were successfully able to deliver the packet on the basis of MAC address because they do not care what is coming from the TCP/IP layer. If it is an IP packet, they will encapsulate that IP packet into the Ethernet, and that is it, right? What is the meaning? I will let you know. And we have discussed about it. So here we have the switch, and you all know that this switch is going to have the interfaces. This is going to be the switch number 1 interface, 0/1. This is 0/2 interface. We will be discussing today how switch works, because when you power on this switch, it doesn't have anything, right? How it is going to learn that 0/1 is connected to Anjali and 0/2 is connected to Rahul? It is as simple as that. And if I say that the Anjali's computer is having this IP address, what is the meaning? The meaning is straightforward, that if we have this Windows laptop, suppose, and if I'm saying the IP address of this laptop is 192.168.10.100, it means that I have opened the network properties of this host and I have set the IP address of this computer, right? How to do that? You just need to go into the network connection, just write Ethernet connections in your search bar in window. It will take you right to that. If you don't believe, let me show you how to do that. Right now I'm on the Windows machine, right? And if I write here network or network status, whatever, right? You can see here, I have here Ethernet. And if I say change adapter options, it will take you to this port, right? And here you go. If I say Ethernet and if I click on the properties, here exactly if you go to the Internet Protocol version, and that is where you see TCP/IPv4, right? Right? And if you see the properties, here exactly you can set the IP address. I have set my IP address, which is 192.168.1.50. You all know about it. If you do not know, that is perfectly fine too. But the whole sole point here is that you can configure the IP address of your machine, right? Just like that, right? So here I have configured, but you must be wondering that Mr. Vishnu, I have never ever provided the IP address to my machine, and still my machine is able to talk to internet. It means that if you are not providing the IP address to this machine, somebody else is doing that, right? And that somebody else is again the protocol. When you switch on your laptop, it is asking that what should be my IP address to somebody, right? Interesting. So suppose you are sitting at your home with this laptop and you open this laptop, you all know for the sure, you all know that you are going to have this Wi-Fi router with you, right? Which is placed by a service provider, maybe Airtel, Jio, whatever the service you are using. So when you open this laptop, what exactly happens? This laptop is actually asking what should be my IP address to this router, and the router is replying back. Interesting, right? You must be thinking that how come my laptop knows about this router? And there is a complete theory behind it, because this laptop and your router are part of the same network. And if they are part of the same network, then this guy can broadcast what should be my IP address to everybody. And if this router understands that request, it is going to reply with this IP address. And that is what this laptop configure the IP address, right? Whatever is provided by your router. And this protocol, this set of rules through which your laptop is getting the IP address, is known as Dynamic Host Configuration Protocol, DHCP. We will be talking about it, right? But I want to give this basic knowledge so that you do not have any idea. So if you are not specifying any IP address to your machine manually, then it must be taking the IP address from Dynamic Host Configuration Protocol, or DHCP. When you come to Cisco's office, when you open your laptop, you must be thinking that I do not have any wire. Still, I get the IP address. It means that you are asking IP address in air to somebody, right? And that somebody is a wireless access point. You connect to it, it is going to provide you the IP address. How it is going to provide it is interesting things behind that. And as I mentioned, if you are curious, I am here to answer, right? So, whole sole point of this discussion is that this guy or Anjali, if I talk about Anjali, got the IP address. Either you have configured manually, how to configure manually, I just showcase you, or you can configure it using the dynamic host configuration protocol, right? But here I have configured the IP address on Anjali machines as .100 and here at .200. But you must have seen that when I was configuring this IP address, I was configuring this IP address over the NIC or the NIC, which is network interface card, which is right there in the Anjali's machine and also in the Rahul machines. I open the setting of this network interface card, which say this is the Ethernet, right? And then I opened this. Believe me, it was showing me the MAC address is already there. If you don't believe, I would definitely like to let you know. I'm opening the command line here, right? Here is a command prompt of my Windows machine. And what I'm writing here is ipconfig slash all. And if you see here, that I am having the IP address 192.168.1.50, which I have configured, right? What is the default gateway? Do not worry about it. I will let you know today. Today is the day of completing almost all the puzzles, right? Subnet mask is this one, 255.255.255.0 means there are 25. So there is another notation of writing this subnet mask. If I write /24, right? It means that initial starting 24 bits are for the network, and which can be written in this way also. 255 means all ones. It means that it is the subnet mask. Sorry, it means that all ones for the first octet, all ones for the second octet, and all ones for the third octet. It means that 24, right? 8 plus 8 plus 8, 24. So you can write in the dotted decimal form also this subnet mask or /24, right? But the important thing is the physical address also, because this is given by the Ethernet, right? Because I have opened this Intel Ethernet connection. This is the Ethernet connection which has come with this MAC address or the physical address. So it is pretty clear for the sure that if we are having this interface, which is network interface card, it is having the properties of physical addressing, which is the MAC address, which you can see right here. And we need IP address also, which is 192.168.1.50 in this case, in case of my computer. Really, really interesting, right? So do not get confused that if I say that this computer is having the MAC address, because it should be there, because it has the Ethernet NIC, and we are also specifying the logical address, which is 192.168.1.1. So this machine is going to have two addresses. Why? I have explained you in the yesterday's class, right? Very, very simple. And now let's talk about it means that whatever the interface, this one is going to have two addresses, and I am not writing that big IP address. I would say Mr. Rahul is going to have the physical address of B colon B colon B. I'm not going to write the 48 bits or the hexadecimal conversion of 48 bits because it is going to be too time consuming for me. I'm choosing only the simple one. So this interface, whatever is connected to this Rahul with this RJ45 cable, at the one end, it is going to have the MAC address, suppose this one, and the IP address is going to be 192.168.10.200. Similarly, here we are going to have the MAC address of Anjali, which is A colon A colon A. and the IP address is going to be 192.168.10.100. Doesn't matter. And if I am not writing the mask, it is slash 24, right? Slash 24 can be written this way, and slash 24 can be written this way also. 255, 255, 255, because here I am saying the starting slash 24 bits are representing the network. It means that starting 24 bits are all ones, which are representing the network, and the remaining 8 bits are zero. If you calculate that, if 8 bits are all one, they are going to give you the decimal number 255. It is as simple as that. I'm extremely sorry I didn't tell you about both of these notation. You can write this as a slash 24, and you can write this as a slash 255.255.2550. But now there must be a question. What should be right? Slash 25. So you all know for the fact, you all know this for sure, that 25 means all 24s, all 24 plus 1, right, is 25. So 24 means 3 octets should be 255. The confusion is on the last octet, what should be there. And the last octet says that only first bit of the last octet is going to be 1, and remaining everything is 0, right? Because the starting 25 bits are 1. The meaning of slash 25 is this. Starting 24 is this one, the 25th is this one, and what is this number in decimal? If you calculate this, it is going to be 128. It means that in dotted decimal form, slash 25 can be written as 128. If I think you all are good enough, right? Interesting. So this board, I am again and again saying it is very, very important because it is giving you some practical exposure. Okay. So what is happening here, guys? I am again cleaning this board. The meaning is we have one network, which is 192.168.10.0/24, which is the gray network, which you can see here, right? Gray network contains one switch. We are calling it as an Ethernet switch, right? And this gray network is also having two hosts, Anjali's host and the Rahul's host. And we have specified two addresses, one MAC address, A:(A:)A. Actually, you didn't specify it came with an network interface card. Dot 100 is this one. Dot 200 is this one. It is as simple as that. How you are going to specify these addresses, it could be the dynamic host configuration protocol or through the manual configuration. By the way, guys, I have done this manual configuration, right? In my case, and there is a reason I will let you know, right? This guy is the switch here. Here is the interface 0/1, 0/2. I will be talking about how these two guys are communicating with each other. But to let you know that definitely I should have something so that I can test whether Anjali and Rahul are talking to each other, right? What should be that? So that I am pretty sure that whatever the network I have created is working, right? So there is a utility which is known as ping, right? And what you need to do is you need to write ping and the IP address of somebody who you want to test whether this host is there or not, right? So what is the host you want to test here? Suppose this is the Anjali's laptop. You have opened the command prompt here, right? And you are writing ping Mr. Rahul. Interesting. But unfortunately, you cannot specify, you can specify the name also here, right? But we do not know till now that how the system is going to convert Rahul to its IP address, because the actual command you need to go in this case is ping the IP address of Rahul, not the MAC address, the IP address of Rahul, which is 192.168.10.200. Interesting. When you write this on your screen, if you see these exclamation marks, it means that everything is working fine. What is the meaning of these 5 exclamation marks, right? Actually, when I write ping 192.168.10.200, it is saying, aha, I am getting some reply. From where I am getting the reply? From 10.200. It is as simple as that, right? You do not believe? Again, let me open the command line prompt. I will ping you, I will show the ping to google.com or maybe the Google DNS server, which is 8.8.8.8. And here you go. But you must be thinking that I do not get any exclamation mark. So exclamation mark, it is simply saying that there is a reply. There are the 4 packet which I get in reply from 8.8.8.8. And it took time 8 millisecond, right? When the server was replying to me. Do not worry about it. We will be talking about everything. What is this TTL also somewhere in this course? But for now, if you ping on window, that window specifically write you that you are getting the reply. But if you are pinging from the routers, will be which Dhaval or anybody else will show you, you will get this 5 exclamation mark. The meaning is actually through this ping utility, you are sending 5 packets. Packet number 1, packet number 2, packet number 3, packet number 4, packet number 5 towards Rahul. And if your network is solid enough, these packets will be reaching to Mr. Rahul, and then Rahul is going to send you replies. Reply number 1, reply number 2, reply number 3, reply number 4, reply number 5, right? These are the packet, whatever you are going to send, these are called the request packet, or we call ping request. And whatever Mr. Rahul is sending back to you, those are going to known as the ping replies, right? So if you get the reply back, your command line on the router will be showcasing you the exclamation mark. 1 exclamation mark per reply packet. If you get 5, it means that you are getting 5 packets back. It means that these two systems are talking. It is as simple as that. So here also in the diagram, if I go and write ping 192.168.10.200 on Anjali's machine, it is going to send some packets. And you all know that the packet is going through these over this wire via this switch, and the packets are going to reach here, and then Rahul will be sending the reply packets, right? 4, 5 over this wire via switch, because this is the only medium what we have right now. But you should understand, if I write a ping and then something with it, it is going to send some packet out of my machine. Those packets are, if your network is good enough, those packets are going to be delivered. And this is what we want to learn today, how these packets are going to be delivered to Mr. Rahul, right? But before that, if I say ping something, you should understand that my machine is ready to send some messages out. And by default, if I do not specify how many packets go out, it is going to send 5 packets out. And the expectation is it is going to receive 5 packets inside also. Interesting, right? But here is the point. Who is generating this ping packet? You must be thinking the application layer should be generated. But the application layer, we have real applications, right? Chrome, we have WhatsApp, and so many applications. But here is the point. Because you just want to change the network, right? You just want to not change. You just want to test the network. You do not worry about what is happening at the application transport layer. So when you write ping 192.168.10.200, just pay close attention here. The network layer is the one who is going to generate this data, this packets for you, right? And ping command is dependent on a protocol, right? So if I say ping, then there must be somebody, right? There must be some documentation that if the system is writing ping, then there must be 5 packets I need to generate. These are the request packet, right? It must be written somewhere in the standard, right? And that standard is known as ICMP, Internet Control Management Protocol, which is used to generate these messages. So if anybody on the router or Anjali's laptop going to write ping something, what this guy is doing, ICMP, it is going to generate the ICMP messages, which are ICMP request message. It is as simple as that. Who is going to generate or where this document or the protocol is written? This protocol is written right there in the network layer. And you should not be confused about it. Why? Because network layer is huge layer. It doesn't mean that it is only its duty is only to deal with the IP address. It is the main duty to deal with the IP addressing. I know, you all know, but it can have some more protocols. ICMP is such protocol, right? Again, I'm repeating, if I'm writing ping 192.168.10.200, the meaning is network layer is generating some ping packets. And believe me, I will showcase you everything, right? So network layer is going to generate a packet which is known as ICMP, and this is ICMP ping. It is going to have some data. It generates some data because it is required to travel to send some data so that Rahul can understand what is there, and maybe this data is 101010, whatever. It is the ICMP ping. But who has generated this? Network layer. But at the end of the day, network layer do not forget its responsibility. You have written that this packet should go to 10.200. Network layer will be saying whatever the ICMP ping has generated, the destination IP address of it is going to be 192.168.10.200 because you have written this way, right? And my source address is going to be 10.100, right? So the IP packet is going to contain the destination IP address, the source IP address, and of course, this message which is generated by Anjali's ICMP protocol, because ICMP protocol means something needs to be generated. Network layer duty is to put some IP addressing on top of it. And that is why we have implemented a protocol inside network layer, which is ICMP, whose responsibility is to generate this message, which is my ICMP ping echo message, which should go to Rahul. Rahul will be seeing this message, and on the basis of this message, he will be replying it, right? So what we are doing, somebody has created that letter for me, right? And I am putting this letter into the envelope of IP, and IP is writing source IP address here and destination IP address. It is as simple as that. But as I mentioned yesterday, if this packet needs to go out, then this packet should be placed into this wire, which is your Ethernet wire. And if this medium is Ethernet, then of course it requires MAC address 2. It means that for Ethernet layer, whatever from here to here is, it is going to be the data, and Ethernet layer is going to encapsulate it or put it inside its own header, which I'm going to write in the red color here, where it is saying the MAC address is going to be, the source MAC address is going to be A colon A colon A, and the destination is going to be B colon B colon B. But here is my problem. Everybody knows that 192.168.10.200 is the destination IP address of Rahul, but nobody knows what is the IP address, the burnt in, or the physical address of the machine. But for now, just try to understand that we know about it. So this is going to be the whole soul packet, or actually this is going to be the whole soul frame, because now we are talking about layer 2 data link layer. Why? Because we have put the MAC addressing. So this is the layer 2 header, guys. This is layer 3 header, or the IP or the network layer. This is the network, this is the data link layer header. This is the IP layer header, and this is just my simple data which is generated by ICMP ping, right? If I say I have written ping, this is what going on inside the computer. It is going to generate this packet. How we are going to get the destination MAC address? It is a different point together. But for now, let's try to understand that if we can generate this thing, if somebody has written ping 192.168.10.200, believe me, what's going behind the scenes, they are generating this IP packet. Interesting. And if I say, I should say these are generating these frames because these frames should be coming out from this physical layer, and physical layer is this one, the RJ45 cable. The packet is going to be flowing over here. How switch going to deal with it, we will be learning it together. But suppose switch is dealing it good, it knows that the B:B:B is connected to 0/2. It will be forwarding it to here. Now Mr. Rahul will be seeing this complete packet. And now Rahul, what Rahul is doing, right? Rahul will be saying, okay, the destination MAC address is B:B:B. This is my MAC address. I should see it. So it will be removing the outer covering. Now it is as good as Mr. Rahul is want to read the letter, but this letter is inside two envelope. One envelope is has been put by Mr. IP. The other envelope has been put by the MAC address, right? Sorry, the data link layer. This is your MAC address. So first thing first, Mr. Rahul is, guys, please be on mute if you do not have any question. I can see that there are somebody who is not on the mute. Okay, thank you so much. So there are two envelopes inside which there is an ICMP message which Mr. Rahul wants to read. So first thing first, they are going to see, okay, this message is for me because the destination MAC address is for me. They are going to remove this red one, means they are going to remove this white envelope. Then he is going to get the green envelope and it will check that, okay, the destination IP address is me, which is 192.168.10.20. It is for me. It is just removing this envelope too. And then it will be receiving the ICMP ping message, which is the echo. Once Rahul machine get this echo message, Rahul machines also know this protocol, which is ICMP. And somebody has written for this protocol that if you are getting echo message, you need to reply immediately back with the echo reply or the ping reply message. It is as simple as that. When you do the reply message, you just change the source and destination, right? How? Rahul machine is going to say now that I have this ICMP reply or the ping reply. It is going to generate this message. Then where it is going to be generated, network layer, by whom? ICMP. Now network layer duty is going to be started. It is going to put the source and destination IP address. And now the destination IP address is what? Destination IP address is going to be the Anjali's IP address, which is .100. You can see I have just reversed the source with the destination, destination with the source, because now the packet is going in the reverse direction. And now if it wants to go onto this network, sorry, this data link layer, somebody has going to put the header of data link, which is going to say now it is wants to go towards A.A.A, which is going to be my destination. B.B.B is going to be my source. It is as simple as the packet is going to be reversing back and it will be reaching. So this is going to be the ping reply packet. So this happened for the 5 packets. If you write ping 192.168.10.200 on Anjali's machine, it is going to generate such 5 packets. Packets are going to be forwarded by the switch. How? We will be learning about it. But the whole sole point is Rahul machine is going to give you back these 5 packets in the reply. And if you are getting these reply messages back, it means that Anjali and Rahul are communicating. It means that you have just tested the connectivity using this ping command. I hope everybody get the ping, right? Although there are so many things which we need to answer right here, but do not worry about it. But before going into a little bit deeper of the actual packet walk, so right now here, I have just specified how ping works, right? So that you do not get confused when I say Anjali is pinging Rahul. It means that Anjali is generating 5 messages towards Rahul, and Rahul's responsibility is to reply them back, right? And now, this is all about how we are going to learn how communication happens inside a particular network. But in today's session, we are also going to understand how communication happens between two networks. So suppose this is my network number 1. right? And now I have another network, which is the green network, network number 2 here. This is 1, this is 2. Believe me, in this network also, I can have many hosts depending on whatever the subnet mask is, and how these hosts are going to be connected together inside this network using this switch. And now, suppose somebody is here with the name of maybe say Dhaval, who is having his laptop, IP addressing, and everything, but he's part of the different network. If that is the case, how Anjali is going to talk to Mr. Dhaval, which is sitting in different network? And that is where we have another piece of a device, which is known as the router. Believe me, guys, we will be actually seeing step-by-step process how these two hosts, Anjali and Dhaval computers, are going to talk with each other. And the point is going to be same. Now Anjali want to check whether she can reach to Dhaval or not. And Anjali is going to write ping, right? 192.168. Now the Dhaval network is 200. So dot 200 dot maybe the Dhaval IP address is maybe 50, 250. And if she got the reply back, it means that the network is working fine. Otherwise not. It is as simple as that. Interesting, right? So I would like to take a pause here. It's already 40 minutes now. I would definitely like to take a pause here to take some of the question. Mr. Dhaval, Mr. Rohit, if we have any question which you think should be answered right now, please do ask.
Uh, there is one question from Abhi Kirk. That's what is net BIOS over TCP IP?
Net bias
In
over to, no, we are not going to discuss that.
yeah.
Anything else?
There was one question from Rachit, which I have answered. His
Perfect.
query was on the configuration screen, which was shared by Vishnu, DHCP was disabled and IP address was manually set.
Mhm.
But if in that network that IP is not available, then what will happen?
Yeah, this is a good question actually, I would say. Even the previous question was also good, but that is totally out of the scope, right? So here, who is deciding that whether the particular address is available or not? I am the administrator of my home network. I know which IP addresses I have given, right? Maybe what I've done is, so if you have seen my network, I was having the IP address 192.168 dot maybe something dot 50, right? Maybe x dot 50, right? Slash 24. I know there are going to be 200, there could be 256 hosts in my network. But what exactly I have in my home? I have one PC, right? I have maybe if I calculate my wife's phone, right? I have two phones, and then one iPad is there, right? And then one TV is there where we are utilizing it. And maybe suppose there are two, three more devices, right? Maybe my wife laptop, my laptop, and so many things. So 3 or 4 devices. If you calculate them, 1, 3, 4, 5 plus 8, I have only 8 or 9 devices, right? So what I did is I have put this range for me, right? And although in my complete network, DSCP is running, so my wife does not need to give this IP address on this machine, right? She just opened the laptop and she got the IP address, right? But I have chosen that range that the DSCP can take DSCP can assign IP address from maybe 100 to 200, right? Because I have a big range from dot 1 to 254. This is my range. And I have asked Mr. DSCP that whenever you get somebody, you can assign addresses from 100 to 200 range. And 1 to 99 is under my control, which I have given to my PC because I was just seeing that whether can I do the manual configuration or not. So this is my addressing scheme. You need to decide, whoever is the administrator need to decide, right? And there are complete software for these IP address management. And that is why your question is really great, because you are thinking, you are curious that how, right? I hope I've been able to answer your question. Anybody else who is having any question, this is the time, guys, to ask the question, right? Otherwise, we will be going really deep into how these two communicate computers are going to talk, although I have given the pretty high level idea, but we are still yet to cover how switch work. Anybody else? Mr. Dhaval?
No, Vishnu, there are no more questions.
Perfect. So let's move to the next board here, which is now I am officially coming into this topic. Guys, one of the most important thing to learn, right? If you learn this, it is going to be very, very good for your basic solid understanding. Believe me, people do not know about it, even if they have experience of 8, 10, 12, 15 years, right? I'm not saying that this is the most this I just want to say this is most important, right, for you. So here is the thing. How do computers talk when they are in same network? So I could have taken the example that where I have one switch which is connected to multiple hosts, but that is going to create that will be cluttering this board. So what I'm done here is I am just starting with only two hosts inside a particular network. So this was my network, right? Which I have showcased in the yellow cloud. So there is one switch here, and there are two hosts, Anjali's and Rahul, maybe, right? I could have drawn many others, but it could have been a problem in terms of clarity of this board. So if I am showcasing you here two a host here, my main point is that how these two hosts are going to communicate with each other. You have a device which is a switch, and you have connected this 0/1 port of this switch to host A, 0/2 port of this switch to host B. Right now, switch is freshly booted. Nobody knows what is inside it, and everything is empty inside this. And I am writing this table. I will let you know which table, what is the name of this table, but actually switch maintains this table, right? What is connected where? So basically it is going to say that the interface, okay, uh, MAC addresses are connected to interfaces. What? It doesn't know because it is freshly booted. And in the process, I will be showcasing you that how Switch is going to build this table. Again, next 20-25 minutes are going to be very, very interesting. Just give your complete attention here. It's a request. Having said that, what is happening here? Host A and host B are connected with this switch over these ports. And over these interfaces, I have configured two things. For host A, the IP address is 192.168.10.100/24. Host B, the IP address is 10.200/24. And by seeing this, you should come to know by now that these two hosts are part of the same network. And what is that network? That network is 192.168.10.0/24. This is the network number, right? And if you can see and if you can know that these two hosts are the part of the same network, even these laptops can know, right? If you can do the mathematics, laptop also can do the mathematics, right? Interesting. And we have assigned another thing, which is MAC address. The MAC address is A:(A:(A), just for the simplicity's sake. If I write A:(A:(A), it is the MAC address of A, host A. If I write MAC B:(B:(B), it is the MAC address of B host, right? And now and this is on the interfaces which I have showcased you, right? Here, I have configured these addresses. Suppose manually for now. Switch does not understand any IP address. That is why it is not having any IP address, because it only understands the MAC addresses. Whatever the packet is coming inside it, it will see the MAC address, and on the basis of MAC address, it is going to forward the packet. It is as simple as that. Or frame. If I'm calling a unit at the switch level, it is going to be frame, right? So pardon me if I make mistake, but if I am saying frame, you should be understanding it is data link layer. If I am calling packets, basically these are my unit at network layer. So frame, packet, I'm going to be using interchangeably, but you try to understand. Yesterday, somebody, day before yesterday, somebody was saying, uh, भावनाओं को समझो, उसमें बह मत जाओ, right? I'm not sure who was that. I forgot the name, right? So try to understand the emotions, right? If I say frame, data link, packet, network, it is as simple as that. So somebody is going here on this computer, host A, and right here, ping 192.168.10.200. And here is the thing. Now you know the history. Now you know how ping protocol work. What is going to happen? The ping will be generated at the network layer, a data, right? And suppose the data is this one. Ping has generated this ICMP data. This is the ICMP request packet, right? And now where it got generated, it got generated on the network layer, and the network layer responsibility is that ping packet should go to 192.168.10.200. So the destination IP address is going to be here, right? Which is 192.168.10.200. It is as simple as that. The source IP address is going to be 192.168.10.100. So this is the packet generated by network layer. It is as simple as that. From here to here, the packet was your IP packet. And of course, in this IP packet, we have the ICMP protocol data. This is the data. This data is not generated by application layer though. Why? Because ICMP protocol has been implemented in the network layer so that you can check pretty quickly the presence of other hosts or not. So you have written, somebody has written ping 192.168.10.200. This host start generating the 5 message. I'm talking about only one message, and we will see that how this message is going to be flowing over via the switch to host B, which is pretty nearby, right? So now what is happening? This packet is generated, and now this host is thinking how to forward this packet. First thing first, this host A wants to know wherever it is communicating, is it part of my network or not? Is it near to me or not? Very, very interesting, right? And you know that yes, you can calculate because 192.168.10.100/24 and 10.200/24 are part of the same network because we know subnetting. This host knows subnetting. It immediately knows that ping 192.168.10.200, this 10.200 is actually part of my network. And if that is the case, it is somewhere here, right? So this complete IP packet I am going to write this way because I am not going to write again and again source and destination in this IP packet. So from here to here, whatever I'm writing this IP packet, it is actually from here to here, this complete packet. Otherwise, this packet length is going to be really, really great. But I will be showcasing you uh, all the things live also, right? On the Wireshark packet. Do not worry about it. So I am not going to write this packet again and again, but I am writing this here, right? And now here is my question. This host knows that the host B, which is having IP address 10.200, is somewhat closer to me. It is in my same network. Actually, the definition of close is not good here, right? But yes, the correct statement should be that this host is pretty near to me, 192.168.10.200, right? Sorry, is in the same network as I am. So what it is going to do if this packet, this IP packets needs to go over this wire. This wire is the Ethernet wire. This computer knows that it has a physical interface, which is Ethernet, which is your network interface card, and somebody has put the RJ45 cable into it. If I want to send this IP packet over this Ethernet interface, I need to put the MAC addresses also. I know my MAC address, which is going to be source IP address, which is, sorry, not source IP, which is source MAC, the source MAC address is going to be A colon, A colon, A. And here is my problem. I have discussed this problem. But at that point of time, we presume that we know the address. But now, here is the problem. What is the destination MAC address? I do not know about what PC Mr. Host B has and what is written, what is physically written there as the MAC address. I do not know about it, right? How would I know that what PC Mr. B has, what model of NIC he has, and what is exactly written on that? Then you must be wondering, how would you know about the IP address? Because IP address is just like your logical address, right? You should know about it if you want to send something. It is as good as that if Anjali wants to send a letter to Mr. Rahul, she doesn't have any clue about the address of Rahul. If she doesn't have any clue about the address of Rahul, then she cannot send the packet, right? It means that addressing should be there. So this addressing, whatever we are seeing in the postal office, this is your IP address because it has some logic. MAC address doesn't have any logic. They are burnt into your NIC, network interface card, right? So here is my problem. I would say, be curious. I would again say, this is the problem which these guys were also facing when they were developing this Ethernet. How would I come to know the destination MAC address, right? And here, if this packet, for example, here is the packet, here is the frame. If this frame is not complete, by the way, guys, if it is not complete, it cannot go out from the system because the whole sole point of this complete protocol is that if you are sending a frame, it should have both source MAC as well as destination MAC. So what is going to happen if this frame is not complete? This host A save this message into this memory and start thinking about how should I get the MAC address of host B, right? What does it has? Host A has the IP address of host B, which is 192.168.10.200. But what it does not have, it does not have the MAC address of host B, right? And this is my problem. Just try to understand the problem. The problem is I know the IP address of host B, but I do not know the MAC address of host B. I need somebody, I definitely need somebody who can solve this problem for me. Means if I know IP address, there must be someone who can give me the MAC address. It is as simple as that. Who is that somebody, right? If I talk in terms of computer networking, there must be some documentation for it that if somebody knows the MAC address, if somebody knows the IP address and they want to know the MAC address, then how to find that MAC address? There is a documentation written, there are rules written in TCP/IP, and those rules are nothing but the protocol. It means that there must be a protocol which is giving me this MAC address, right? If I know the IP address, and that protocol is actually address resolution protocol. It is as simple as that because you want to make a correlation between IP address and MAC. If I know IP, what is the MAC? This is the protocol which is going to help this machine, right? Or eventually to you. And Ethernet developers were talking about it, that there is going to be a problem. I do not know what is the MAC address. I know only the IP address. What should be the MAC address of this machine? And they have to write some rules. They have to write this complete protocol just to solve this problem. And now we will be talking about how address resolution protocol is going to give you the IP address, sorry, the MAC address corresponding to a particular IP address. It is as simple as that, right? So I'm repeating the process once again. Somebody has written ping 192.168.10.200. It means that they want to send some packets to host B. The packet has been generated. ICMP is the protocol which generated the message, and then IP layer has put the source IP, destination IP. But this packet, if it wants to go over this wire, it needs the MAC addresses. We know source MAC address because I know this is my source MAC, but I do not know destination MAC. This packet cannot go out. Why? Because the packet or the frame is not completed yet. And that is why this host is storing this into its memory and start thinking about how to resolve the problem of destination MAC. And it comes to know that there is a protocol which is address resolution protocol which can help me by which can help me knowing the MAC address if I already know the IP address, right? And here is that protocol. So the yellow message is whatever you're seeing here, right here. Now, this packet, just forget about whatever the packets you have generated, ICMP packet or this packet which is into the memory, right? Now the host is in different mode altogether. It wants to know the MAC address, and that is why it is taking the help of address resolution protocol. This R is actually just like some rules, just like your ICMP protocol, right? ICMP protocol was creating this message. What message? Echo message or the request message. Now we are talking about ARP, how ARP is going to work. So ARP is actually have 4 specific fields in it, right? What problem? First thing first, I think you all understand what the problem ARP is going to solve. ARP is going to solve only one problem. It is going to give you the MAC address of host B, right? So our protocol generates its own message because now this host wants to take the help of ARP, and this host is saying, Mr. ARP, can you solve my problem? I have the destination address 192.168.10.200. Can you give me the MAC address associated with it? And ARP is saying, absolutely, yes, this is my work. And it start doing its work. There are 4 fields in this packet which is generated by ARP. Number one thing is sender MAC and sender IP, target MAC and target IP. What is the meaning of it? Right? Sender MAC means ARP is saying, I want to know I want to know somebody's IP address, right? And I'm giving my information. I am the sender MAC. Sender MAC is A colon A colon A. Sender IP is definitely what? Sender IP is going to be 10.100. Target IP, what? Uh, I want to know MAC address, but for what? I want to know MAC address for 10.200. I'm not writing the initial 2 octet, guys. You should understand it, right? And here is my problem. Again, ARP is also dealing with the problem. It doesn't know about it. So while creating this ARP packet, it is saying that I will be having the placeholder 0.0.0, right? That is okay. But this is the packet generated by our protocol. It has to reach here to host B so that host B can understand that this is my ARP request message. ARP is saying what is the MAC address associated with 10.200. It should be reaching here from here to here. And this is again the same problem, right? If I could have forwarded the packet, I could have forwarded this IP packet, right? With this MAC address. And here is the thing, ARP has generated this standard message. The meaning of this standard message is who is having the IP, what is the MAC address corresponding to IP address 10.200. So whatever you have written here in the yellow, the meaning is, see, I am the source, right? I am A colon A colon A. My IP address is 10.100. I want to know the MAC address associated with 10.200. I do not know it, right? So this is the ARP message which was generated by the ARP protocol. We call this as the ARP request message, right? This ARP request message, I do not want to write the full 4 forms again, and that is why I'm writing ARP here. This is the ARP request, right? What does it contain? It contains these 4 fields. But at the end of the day, this is the data, right? It should go and reach to host B so that it will be saying that, okay, this guy doesn't know my MAC address because it is written 0:0:0. I should be providing. But how this ARP message is going to be reaching here? And that is where, at the end of the day, this ARP message should go where? Over this wire, right? This wire, and this wire is the Ethernet wire. So what is I'm going to write? I'm going to write source IP address first. Source IP, sorry for that, because this is the MAC address. Sorry, this is the cable where only MAC addresses can flow. So that is why I'm going to write destination MAC and source MAC. The source MAC is going to be my A:(A:)A, and destination MAC again I do not know. And that is why yesterday we were talking about the broadcast, right? How Anjali was talking to Rahul. First thing first, she came into the room and shouted, right? Hi Rahul, how are you? It was listened to everybody else, but Rahul was responding. And that is why the broadcast come into picture, right? So this ARP message, whatever was created by this ARP protocol, is be broadcasted. And in this protocol, we have explained to everybody that if something is coming with F:(F:)F, it should go to all the ports of the switch. Interesting. Try to understand what we were sending. We want to send this ICMP ping message. We have encapsulated this message into the IP packet, but we couldn't send it because the destination MAC address is not there. This host wants to complete this packet, but destination MAC address was not there. I am taking the help of ARP protocol. ARP has generated its own message. This message even should be going over this interface, and it means that we need to include the same source and MAC address, but we do not know about the destination. And now ARP is actually sending this message on a broadcast address. It means that ARP request message is the broadcast message so that it can reach to everybody. If you are having some doubt, let me complete the entire process, and believe me, you will be amazed to see that what happened when two computers talk, right? Now, ARP message is going to be put on this wire. We are fulfilling all the condition. Why? Because we are placing the source MAC and destination MAC addresses here, and this will reach into the switch 0/1 interface. Interesting, right? This packet, the complete packet, which is having the source and destination MAC address, which is F:(F:)F. Sorry for this. F:(F:)F, and source is A:(A:)A. And then basically we are having this ARP message inside it. And what is this ARP message? This is a big message which contains all this information, by the way, right? And now switch is getting its first packet of all Fs. And here is the thing, here is the intelligent thing which switch does. Switch is saying that there is some packet coming to me, some frame coming to me, right? The frame is coming with me this source MAC address, and it wants to go to this destination MAC address, right? And when it sees the source MAC address, don't you think, guys, now switch is intelligent enough to know, because it has received a packet over 0/1 interface with the source MAC address, this one. It means that switch is immediately saying that MAC address A:(A:)A is connected to 0/1 interface. It is as simple as that. And that is how switch is building this table, which is going to be very, very important. I will let you know, right? So our broadcast message is coming. Switch is checking its source MAC address. Don't you think that it is straight away saying that this message is from A:(A:)A, and if it is received on 0/1 port of the switch, then this host, which is having the IP address A:(A:)A, is connected to 0/1 interface, and that is why the switch has written this thing, right? Interesting. But now switch learns this table, or fills this table on the basis of what? It fills this table on the basis of source MAC address. But Switch job is not to just create this table. Switch job is to forward this packet, right? Or the frame, whatever you are receiving, the ARP message frame. And it is going to be done on the basis of destination MAC address, which is F colon F colon F. And I have written into this protocol rule that if a switch is getting a frame which is having an IP address F colon F colon F, it should go to everywhere. It means that suppose if a host is connected here, maybe 0/3 interface, this packet should be forwarded here. This packet should be forwarded here, 0/2, everywhere. If there are 24 ports on the switch, which are part of this network, this should go to everywhere. But do you think that it should go back to this interface? No, because at the first place, we have received this packet or the frame from this interface itself. So switch will send the frame with F colon F colon F on all the interfaces which are part of this network, right? Apart from the interface which is from over which it is getting this message. It means let not clutter this diagram. We are not putting some more routers here, sorry, more host here, but we know that if it is a broadcast message, switch will see the destination MAC address. It will be forwarding this message on the base on here, right? And it will not forward this message here. Why? Because at the first place, switch receives this message or the frame over this interface. So there is no point of sending it back to this host again, right? And that is where this packet is going to be here. Now the packet, of course, will reaching the destination MAC address is F colon F colon F. The destination source MAC address of this packet was A colon A colon A. And this was your R packet. What was inside this R packet? Inside this R packet was these information that it has sent by A colon A colon A, right? It was sent by the IP address 10 colon 100. It is for 10 colon 200, and we do not know what is the MAC address of, and this is my request. Can you tell me 10.200 that what is your MAC address, right? So what is going to happen? This broadcast frame or this broadcast ARP message is going to be received here, and host B is saying this packet is having F colon F colon F. And I have written into this host B also that if you get a frame with F colon F colon F MAC address, it is your responsibility to check what is inside it. And that is how it is going to check what is inside it. So F colon F colon F means everybody is going to open it, even if there is another host or there are many hosts here. They are going to open this message because this is for F colon F colon F. It means that F colon F colon F should be opened by everybody. What is the meaning of opening? This was your letter. Our message was your letter. It was inside this envelope. It means that you are removing this envelope from here. Who is removing? Host B. It will be seeing this ARP message. ARP message is going to contain this. And inside this ARP message, host B will be seeing, okay, this message is for this target IP address, which is 10.200. And 10.200 is me, right? And ARP protocol is actually asking me what is the IP, what is the MAC address at 10.200, and I should be replying because I also understand address resolution protocol. So it means that if this guy understands TCP IP, this guy should understand TCP IP so that they can communicate. Inside TCP IP, if this guy is having ping, this should have the ping so that both of them understand the ping. And if this guy is using address resolution protocol, this guy should also be using address resolution protocol, right? They both understand, and that is why they are communicating, right? Protocol means some rules which both of them understand, a language which both of them understand. ARP is understandable by A, ARP is also going to be understandable by B. If in our protocol it is written that if somebody is sending the request for you, you need to reply that request with the ARP reply packet. It means that you need to tell what is the MAC address associated with 10.200, because at the first place, ARP is solving that problem, and I have written that problem exactly here. Interesting, right? So what we are going to do now, this packet is received at host B, the ARP request packet, and we still have this problem that this host packet was in this memory. This host could not send it because we do not have the destination MAC address, and that is why we were taking the help of ARP. ARP has sent the packet. ARP is packet here. This host has decapsulated. By the way, guys, if I am removing this envelopes, the meaning is I am doing the process of decapsulation. Previously, when I was putting this letter inside, that was encapsulation. So we are introducing terms also along with it, right? So now what I'm going to do is I will be showcasing you how host B is going to reply the MAC address associated with 10.200 in the ARP reply message. It is going to be very, very interesting, right? But before that, I would like to take the pulse here, right? Dhaval, can you hear my voice clear and loud?
Yeah, Vishnu.
Perfect. So what I'm going to do is in the next board, I will be explaining you how the reverse ARP is there, right? So by the way, what I've done is I have already written down all the things here. By the way, I forget one thing that we have here, the ICMP thing, right? And this IP packet was stored in the memory, this one. Maybe the source and destination MAC address position is get changed. Do not get confused with it. So basically, this is my source IP. This is the destination IP, right? And this is the source MAC. This is the destination MAC. This is my IP packet. And this was stored in the memory. And basically here, we are taking help of ARP. ARP is having sender MAC, sender IP, target MAC, target IP. I cannot send this ARP message alone because it needs to go over this Ethernet wire. That is where I'm putting the source MAC address and destination MAC address. Destination MAC address was F colon F colon F. This message reached here, and that is why switch learned SKM table. Only the first thing. How it is going to learn the second thing, I will let you know. Right now, it is not there for sure, right? So this message reached here, and the message is got delivered to this guy. And now this guy has read this message, and now it is in the process of creating the ARP reply, right? The message structure is going to be again same sender IP, sorry, sender MAC, sender IP, target MAC, and target IP. Now it was replying for the ARP message which it already got in the previous board, right? The sender MAC now, who is the sender now of this reply message? The sender will be host B, right? And that is why the sender MAC is going to be B colon B colon B. Sender IP is going to be 10.200 by why? Because now this is the sender of our reply message. Target MAC, where exactly it is replying back to? It is replying back to A colon A colon A. Now it knows that this reply message is or the previous request message which was coming from A colon A colon A. Now it knows, and the destination is going to be 10.100. It is as simple as that. But this ARP reply cannot go as it is because if you want to place on this Ethernet, it should be having the source MAC and destination MAC. So basically here we are putting this ARP message here, right? Source MAC is somewhere here and the destination MAC is somewhere here. So source MAC is going to be B colon B colon B, and now it knows the destination MAC. Why? Because it knows where to send this ARP reply message because of the previous message it got received, right? So it knows that it should go to A colon A colon A. You should be understanding that why the destination MAC is A colon A colon A, because previously you received the message with this was the message, right? This was the message which got received. So that was having the source MAC address of this one, and that is why, because you are replying back, the destination MAC address is going to be A colon A colon A. It is as simple as that. And now something happened on this switch too. Switch will fill a scam table on the basis of source MAC address. Now somebody is saying that this packet with a source MAC address B:B:B is received on 0/2 interface. It means that this switch is intelligent enough to know that the 0/2 port is connected with B:B:B, and that is how switch is filling its table, which is known as MAC address table, right? Or in other, there is another name, that is CAM table, content addressable memory. You can say CAM table too. Very, very interesting, right? So now this ARP reply is going to be back here, right? And now this guy is opening, and you know that how okay, sorry for this, sorry for getting one step ahead. So this packet is going to be reaching here. The number 1 and number 2 entry is already there, and now this packet wants to go to A:A:A, right? This packet, if I write from the green color, this packet will be here on the 0/2 interface, and switch will forward the packet on the basis of destination IP address. So it makes the table on the basis of source MAC, and you understand why, and destination IP address on the basis of it is sending the packet, right? So this time destination MAC address is not F:(F:)F, so it is not broadcasting it. This time the destination MAC address is A:(A:)A. It is going to check that yes, I know where to send the packet for A:(A:)A. It should be go out over 0/interface, and that is why this packet will be received over 0/2 interface and will be going out over 0/1 interface. It is as simple as that, right? This packet with source address, destination address of A:(A:)A and source address of B:(B:B will be received here. And what is inside this? Inside this, there is going to be the R packet, right? And this is our reply packet. By the way, the previous packet, the request packet was the broadcast packet, right? And the reply packet is your unicast packet. Why unicast? Because there is one-to-one communication now going on. Switch has learned is CAM table. And now this host A is going to open this ARP reply. It is going to see 4 fields in it. What 4 fields? Sender MAC, sender IP, target MAC, target IP, and target MAC is going to be A:(A:)A. Target IP is going to be 10:100, and of course this packet is for them, right? And the source MAC is going to be B:(B:B, and the destination is going to be 10:200. Don't you think that through this computer A knows that the MAC address corresponding to 10.200 is B:(B:B. It is as simple as that. Now these guys know, right, that the destination MAC address, because previously it was not able to send this message, and the reason was there was no destination MAC address, right? But now, once we receive the ARP reply message, we have seen that the destination MAC address for corresponding to 10.200 is actually B:(B:B. This host is going to create this complete packet B:(B:B, and now it can send this frame which was stored in the memory to directly here. This frame is going to reach here. The destination is going to be B:(B:B. The switch has already learned B:(B:B is reached by a 0/2, and the first packet will go like this. The second packet is again go like this. Third packet, and what packets I'm going to talk about? I'm sending now this ICMP messages, right? ARP has just completed its duty. ARP has given the MAC address associated with 10.200 via the ARP reply. Once this guy gets the ARP reply, it can able to complete the packet which was stored in its memory. It will complete the packet. It will complete again the 4 more packets, because the ping command sent 5 different ICMP packets. Now the packet can be unicasted, and the reason is we know where the destination MAC address is. What is the destination MAC address associated with 10.200? This switch has learned its CAM table, and Now 0/1, sorry, host A and host B can easily communicate with each other. You must be wondering that is this what happened when you write simple ping? Absolutely. So I'm again saying one thing, number of steps. First, ping is generated. Ping is encapsulated in the IP packet because IP packet cannot go over the Ethernet. That is why you need the MAC addresses, right? And that is what you're going to do. You are going to take the help of address resolution protocol to know the destination MAC address because you do not know. ARP is going to give you the destination MAC address by following the process. Means ARP is generating the request message. It will be broadcasted. Switch will broadcast it to everybody. Then the host B, because this ARP packet is directed towards it, it will be reply. ARP will give this host again the MAC address of the destination. And in the meantime, Switch is learning its CAM table 2 on the basis of source MAC addresses. At the third step, this host can send and receive messages. It is as simple as that. Okay. So now I will be open for questions. Anything, even the slightest of doubt, maybe. I'm not saying 2 plus 2 also. If you do not get, please do ask. Mr. Dhaval, do we have any questions?
Rachit has raised hand. Rachit,
Yeah, Rachit, go ahead.
you can unmute and ask question.
Okay, perfect. So shall I presume that everybody got how to computers talk when they are in same network?
Hello.
Yeah, please go ahead.
Okay, I'm audible, right?
Yeah. What's your name first?
Rachit, I'm Rachit.
And thank you so much, Rachit. You are the first one, and there is a chocolate for you, maybe when we meet, right? You are the first one who is
thank
asking the question by raising the hands. Thank you so much for that. It's in the fourth class, but yes, please do ask the question.
I wanted to ask, like, the cam table is being prepared in the switch, and like, if like it is there, okay, the MAC addresses and the interfaces are there. Like, if I have like, if my host A wants to send the ICMP and it is not having the MAC address of host B, right? And switch is having, so it will get the MAC address from the switch only, or the whole IRP will go till host B and the same process will repeat.
Pretty interesting question. So, believe me, Rachit, there is no communication happen between switch and this host. If you have hard coded also this, for example, the problem of the ARP message, and this is very interesting question, right? The problem which ARP was solving is what is the MAC address corresponding to B:B:B, and now somebody is saying that this switch knows. I do not know how, but this switch knows, right? First thing first, if I let you know, Mr. Rachit, switch doesn't deal with the IP address. They do not know which IP address have what MAC address. If you see this table, it has only MAC and interfaces. They do not know what is IP address. Although the complete packet is going, so they do not know about the IP address. So first thing first, they cannot tell about it, right? But the second point, suppose they know about IP addressing also, suppose in case, right? So I would let you know that host actually do not ask anything with the switch because switch is incapable of doing that, right? Switch just forward packet on the basis of whatever it receives as the source MAC and the destination MAC. It does not have the intelligence to check what is inside this packet, whether this is the R packet or ICMP packet. I'm not saying this is happening with all the switch because nowadays whatever the switch is coming, they can do routing also, right? But if I am saying switches, those are the normal layer 2 switches, right? They do not worry about what is inside the packet. They just see that, okay, this is the destination MAC. I should be forwarding it on the basis of whatever the CAM table I have developed. If there is an entry, I will be forwarding it. Otherwise, I will be discarding it. It is as simple as that. I think, Mr. Rachit, I am able to answer your question.
Yes, Vishnu, I got it.
Perfect. Anybody else? Anybody else? You can straight away raise your hand. Whatever come to your mind, please do ask.
Vishnu, there is one more query from Sanya.
Yes, Sanya. Yeah.
query is if the message is broadcasted
Mhm,
and the destination address is unknown,
mhm.
then how to protect the network from being hacking or attacks?
It is again a problem, right? This is very good question again, Sanya, and I'm again very happy that you are curious enough to know. So you all know for the fact that there is a problem in the ARP, right? The problem in the ARP is that you are sending a particular message which is going over the address which is F colon F colon F, right? And the switch is connecting with multiple hosts, and there must be somebody who is not good. What is the meaning of who is not good? The meaning is he is a hacker. He wants to gain some information. And believe me, there are attacks on this. Believe me, if you get to this point that ARP is a protocol which is sending message, with the first message of it is which is it is broadcasting, it can reach to anybody. This guy can take undue advantage of that, right? How? To learn that, you need to understand more networking. But yes, this guy is also getting this packet. But this should be part of first thing first. This should be part of their own network, right? And yes, most of the attacks which happens are from the known people, right? People say that there are attacks on the industry from outside, but around 60, 60, 70% of the attacks, even 80% of the attacks come from the inside. So maybe this employee or this some of your friend is not good, and he can capture these messages, the ARP message, and can take the undue advantage, right? And there are some mitigation techniques for this, right? How we will, first thing first, we need to understand through this ARP message what information can he get and what undue advantages can he take at most, right? And then we need to think about how to mitigate those effects. And there are some cool technologies implemented in the layers or the switch itself, which can uh, which can definitely mitigate or remove such problems. But to understand that, you need to be curious and you need to learn more that what is there in this ARP message so that this guy can take advantage. There are some security sessions also in the CCNA, and probably I can take it there. But yes, this is an amazing question which proves that yes, you are giving some thought on the process, whatever we have learned. Having said that, is there any other question, Mr. Dhaval? Dhaval, do we have any
Mm,
other question?
yeah, there is one.
Yeah, go ahead.
Yeah, there is one which I'm answering.
Hmm.
So the question is like, in a class C network, right? We have 254
Hmm.
hosts. So can a switch in this network can have that many interfaces to connect with those hosts?
Very nice
So I
question.
was
Very
just
nice
answering.
question. Who has asked this question?
Monica Devi.
Monica. Monica, thank you so much for the lovely question. So basically, she is saying that if we have this switch, right, and you just mentioned that this is slash 24 and everybody is connected to this switch. What if this having 254 hosts, can we have these many hosts here? Sorry, these many ports on the switch. So generally switch comes with the slash means 48 ports or 24 ports or 12 ports only, right? But what if we have a huge network? Maybe you can have slash instead of slash 24, you can have slash 23. Now we are talking about 512 hosts, right? Interesting. Although we want to shorter this broadcast, we want to have a shorter network, but your question is still relevant. That what if we do not have so many ports on the switch, how we are going to connect multiple hosts with this switch? And if that is the case, what is going to happen? You need to take help of another switch, right? And then you need to connect these switches. Then you must be thinking, okay, 12 ports here, maybe 48 ports here, now 60. What next? Bring add one more switch and connect it and connect the host to it, right? And this question, whatever you asking, is basically making your switched network. This should be part, the first thing first, you all know that if there are the switches, we are talking about the same network. All these switches should be part of the same network. And here we are having multiple switches, right? And this is your switched network. And believe me, in switch network, there are some problems too. How you are going to connect these switches? What should be this interface look like? Whether this is any standard interface, right? We will be talking about it. So the next week, the first thing first, we are going to talk about these switch network. Yes, you can have multiple switches, but they can cause some problem. And if you see that I have 3 columns in this MAC address table, right? It is not by mistake, everybody. We have column number 1, column number 2 is for MAC addresses, column number 3 is for interfaces. But what for column number 1 is, this column number 1 is going to represent another switching concept which we are going to learn. If you have heard about VLANs, we will be introducing VLANs. Why? Because when we see that there are multiple switches, there are some more concepts like trunks, like VLAN, we are going to talk about. But yes, I am amazed to see that you are thinking along this line that if we have multiple switches, then what is going to happen? Thank you so much. Any other questions, Mr. Dhaval, we have? No?
No, Vishnu.
Perfect. So this is the time. And I could see one question from Monica, and she's saying that when we do ARP, we get to know the IP address of the destination. That is perfectly fine. But do we need to do this process again and again? Address resolution protocol. Actually, you are absolutely right. And again, thank you so much for thinking in this regard. We do not need to do this every time. What a particular host does when it wants to communicate to another host, maybe the B, it will initiate the ARP, right? And once the ARP is done, it will cache this address into its memory, and we call this as ARP cache, right? So before doing the ARP message, before sending the ARP broadcast message, it checks whether the ARP cache, do we have an entry in the ARP cache for host B? If we already have, then we do not need to do this complete process. It is as simple as that, right? Okay, you can lower your hands. That's fine. And what we can do now is we can start over the next board. And by the way, guys, if you are confused about how these packets look, let me showcase you these packets here on the Wireshark. Although I have just taken the screenshot, but believe me, I can give you this complete file. You just need to install Wireshark on your laptop. Just import this file and you will be good to go, right? So what is happening here? The same thing is the network is absolutely same. We have host A, but here the IP address of the host A is actually something like this, right? It's a 48-bit IP address. So should say 50:00:02. So let's say 02 should be the identification, and there is a host B, right? And the host B IP address is, sorry, MAC address is 50:00:02. The IP address is going to be same, which is 192.168.10.100 and 192.168.10.200 is the IP address of B, right? We have a switch in between, which is just forwarding the packets, right? Do not worry, we will show you the CAM table of this switch also. But as you know that when we initiate a ping packet from here to here, from A to B, what is exactly happened? Do you think that the IP packet is going to come out, the ping packet is going to come out? No, absolutely not, because the packet is not going to be completed unless we have the MAC address of B, and that is why the first thing first we are going to do is we are going to send the ARP message, right? And how this complete ARP message is going to be looking, we have this ARP, right? The complete ARP, which is going to have this 4 fields: sender IP, sender MAC, sender IP, sender MAC, sender IP, target MAC, target IP, right? And then we are going to encapsulate, because this is just like a letter which Anjali has created, and we will be encapsulating it into the envelope, and this envelope is going to be this, what we call the frame, right? Or the MAC addresses. So exactly in this way, you will be seeing this message in the Wireshark. Believe me, you do not need to worry about the first thing, whatever you are seeing, the first line over which I am. You do not need to worry about this line where this frame is written, right? This is the pseudo thing which is created by the Wireshark. You do not need to worry about it, right? We should be seeing the packet from here. So the first thing first, here is the ARP packet which is having these 4 fields, right? This is the ARP message generated by the ARP protocol, address resolution protocol, right? And the most important things, although this is having some other fields also in the packet, right? But the most important things are sender MAC, sender IP, target MAC, and target IP. This is something which is generated by our protocol, and you can see this is the request message, right? It is having these 4 different fields which are very, very important. This is the sender IP address 10.100. This is the target IP address 10.200. Here is the sender MAC, which should be :02. You should be seeing something here. And the target MAC address, we do not know anything about it. And that is why we put 0:000. And you can see here, the target MAC address is 0000, all zeros, right? Because we do not know about it. And this is the something which is created, this message, the ARP message, the ARP request message is created by ARP protocol. If it wants to go to this wire, you should be including source MAC and destination MAC. It means that whatever you are seeing here, it is just like the letter. You should be encapsulating it into the bigger envelope, and the bigger envelope is going to be your Ethernet header, right? So you have this ARP letter, and now you are going to put this letter into bigger envelope, which is your Ethernet, which you are seeing right here. And the source address is going to be this one, of course. And you all know that this ARP packet, which is inside this envelope, we do not know the destination MAC address, and that is why we are sending it to all Fs. So the source MAC address is going to be this one. The destination MAC address is going to be the broadcast, which is this one. Interesting, right? So this is what we are seeing here. This is the Ethernet header, which you can see here. And here, from here to here, is the actual ARP message, which is having all these fields. I think you should be clear with this. And try to understand what this Wireshark is saying, right? That the first message which is coming out from here is the broadcast message. This is the ARP message, and it is asking literally, just see what's the meaning. Who has 192.168.10.200? This is the meaning of this ARP, right? It is asking that who has 192.168.10.200? Tell 192.168.10.100. Otherwise, this host 10.100, this one will not be able to send the packet, right? And literally Wireshark is decoding this message for you, that this is the request message. Who has 192.168.10.100 in the network? This guy is 10.200 in the network, right? Tell about it to 10.100. This is the meaning of this ARP message. And now just have a look at what is the reply we are getting. We are getting the reply 192.168. So whatever the packet we are seeing right now, this packet from here to here is the packet number 135, the ARP message, right? What is 136? 136 message is the reply, and we will be seeing that reply message right here. So this is the address resolution packet, our reply message, right? And reply is actually coming from column 3, 50:3, which is my host B, right? You all know about it. We have written this. This was my host A, .100.200, which was there between, right? And by the way, I have created this setup in my simulator. and then take out these outputs, right? You can also do that. How? We will be letting you know. But now it is saying that the reply is from 50 colon something 3 MAC address. Here you can see this is the source of the reply. This is the destination of the reply. Destination means 00 colon 02, 50 something, right? So it is saying 192.168.10.200 is at this. It means that it is the reply message, right? And again, the reply message is going to contain what? Address resolution protocol message, which is generated by RPET-B, and where it is going to be sent. This time it is going to be the unicast message, which will be delivering towards the A colon, sorry, yeah, A colon A colon A. And that is why we are seeing here, this is the address resolution message, right? Sender MAC, who is the MAC sender, right? This time the sender is going to the destination, which is B, and that is why you are seeing colon 3. Sender IP address is 10.200 because this is the reply message. And you can see here, this is the reply message. Target MAC address is going to be this one, right? A, and the target IP address is, this is what we learned in the theory. We are exactly seeing them, right? This is actually how your packet looks. And now, if I talk about, this is the letter or reply which is created by the destination B. Now you are going to put it inside the envelope and send it back, right? This is the Ethernet header which you are seeing right here. Guys, this type of understanding is required. This type of clarity is required, right? So destination is going to be colon 2 and the source is going to be colon 3. It is as simple as that. And this is also deals with only the destination and source address, right? Although there are some more fields in Ethernet header, but we are actually concentrating more on the destination and source. It is as simple as that, right? Would you like to see the ping packet also? How the ping packet looks like? Let's see the ping also, okay? Here you go. If you have any doubt, any question over this screenshot, please do let me know. If I see here,
There's a question,
mhm,
Vishnu, from Sai Lasya,
mhm.
asking what is padding. So I've answered it like random bit, but if you can throw some light.
That is fine. These are some of the, because if you can see that even IP packet, which we are going to discuss pretty soon, it is just not the source IP and the destination IP. There are so many things there too. But here we are first learning the most important pieces, right? Pairing is just to complete the packet itself. Not that important, but yes,
Yeah.
to complete the information, we will be letting you know, right? Any other question, Rohit, do we have here? No,
No,
yes?
Vishnu. This
Okay.
is correct.
So let's now see what is a ping request, right? And as I mentioned, do not forget about this diagram. Always you should be seeing this diagram as I'm mentioning that the ICMP protocol is at layer 3, which is the network layer, which also deals with the IP addressing. And then basically there is a data link layer, which deals with the MAC addresses, and then physical layer where the packet goes out, right? People say TCP/IP, they just learn once and then they forget about it. Believe me, whatever technology you are learning, whether it's SD-WAN, whether it's ACI or anything, if you see every packet from this perspective, you are going to learn that technology pretty easily. And that is why in the first session I told you these are going to be your fundamentals. If you know them, the new technologies learning is going to be piece of cake for you. Otherwise, it is very, very difficult, right? When people say SD-WAN is difficult, when people say uh, ACI is difficult, actually these technologies are not difficult. The problem is we don't have the basics or the fundamentals strong. Okay. So having said that, where this ping packet came from, right? Ping packet is generated at the layer by the ICMP, right? And then this is the data for me. IP packet will be taking it and encapsulating in the IP header. And then eventually, if this packet wants to go out of the Ethernet interface, the frame or the layer 2 is encapsulating it into its, right? So if I think in the terminology of my letters, right? Postal service. First thing first, what is happening here? Somebody has created this letter, right? Where we have write ping. And then here comes the IP, right? IP protocol knows that if this message wants to go somewhere, I need to encapsulate it into an envelope, and I should be writing the source IP and destination IP on top of it. I should be writing more parameters, but those are the parameters which we need to discuss more. And then if this IP packet or this envelope wants to go somewhere else, I need to put it inside another envelope, which is my L2 or the data link layer header, which is going to put source MAC and destination MAC, right? If I open the green envelope, I will be finding the orange envelope. If I open the orange envelope, then I eventually finding the message. So if I start with the message itself, believe me, the message is right here. It is generated by the protocol Internet Control Message Protocol, right? What is this message? The message contains ping request. It is as simple as that. So this complete letter will be encapsulated where? By the IP protocol. And here we are seeing the IP header. It means that this complete information, if I write, I should show it with a green pen, right? So here, from here to here, basically my complete IP which has encapsulated this message, and here is my internet protocol or the IP header. The most important or promising field which we have learned is the source address. The source is going to be for sure. Source will be 192.168.10.100. The destination is going to be 192.168.10.200. It is as simple as that, right? Although you can see there are so many fields. Time to live is there, identification is there, differentiated services fields there. There are so many things also, right? Interesting. And now let's talk about, or I am extremely sorry, I should showcase it with the orange color so that it goes with our analogy, right? So here is my orange color here. So from here to here is the first envelope which contains what? Which contains Internet Control Message Protocol. This is my first envelope, right? And here I have written what? Source IP address and destination IP address, which is the most important thing which we have learned, right? Although it contains many more fields. And if this message wants to go over the Ethernet wire, you all know that we need to encapsulate it into another thing, which is my Ethernet, right? So here is a bigger packet, bigger envelope, which is containing all of them. Sorry for my drawing, but it is like this is the bigger envelope, right? And Ethernet source is going to be this one, destination is going to be this one. I think you got the point, right? And this is how you are going to read the packet. And similarly, if I want to showcase you the ping reply packet, the reply will be just exchanging the source and destination IP addresses, right? And now I am talking about this packet which is coming to you, the same thing, right? We are having here internet, sorry, ICMP right here, which is encapsulated in internet protocol. The source is going to be changed. Now it is 10.200. Previously it was 10.100. Now it is going towards 10.100 because it is the reply message. And you can see right here that this is the ping reply message, right? And then it is again encapsulated into the Ethernet. You can see the source and destination address is changed. Okay. So there is an application name as Wireshark, right? So I want to showcase you that if I share this information with you, okay, What informations? Do we have something here? Wireshark, trace file, and I have something for address resolution protocol. If I send this file to you, you can open this file straight away, right? And if I open an ICMP message here, you will see that these are the messages. This is the filter, whatever I have put. And on my website, pretty soon you will be seeing a neat demonstration on Wireshark, that how you can use Wireshark, right? So basically, if I click on the first packet, which is going from the 10.100 towards 10.200, right? You are going to see frame. I'm not interested. Ethernet is something this. Internet protocol is something this. And here, the ICMP, which we have discussed, right? And on the right hand side, if I showcase you, just have a look at it, how it is creating the neat and clean Ethernet header for me. Then basically ICMP header, sorry, Internet protocol, and then ICMP header too. Interesting, right? If you really want to go deeper, as I could see, there were a lot of curiosity that how you are going to secure your network. First thing first, if you want to know how to secure your network, you should be having good understanding of these packets, right? This is the CCNA course, which is going to build your fundamentals. And believe me, in 40 hours or in 30 hours, whatever we have for the next 10 days, I cannot teach you each and everything. So we need to make sure that we choose the domain. Whatever should be outside of the CCNA classes, I should be leaving that. But if you are so curious to learn, believe me, I have a course on network security. I have a course on deep routing protocols like OSPF, BGP, MPLS on my website. I have a course on very fundamentals of so many technologies there. SD-WAN, if you want to learn, it is there. But for that, learn first the CCNA. So whatever you want to go into a little bit deeper, and if you want same kind of whiteboarding, which I like to do, that is right there on the courses. But this should not be the only place where you are learning your networking. Although Bridgewire is the best, I'm pretty sure about it. But there are so many places where you can go. Cisco is going to give you the access of O'Reilly books, right? And there you can find any book and you can start learning it. You are going to get the access of digital learning where there are so many courses, whatever you would like to learn. Okay, it is right there. Having said that, this is what I wanted to showcase you, right? But still, what we have learned till now, that if we have a huge network, and huge network means internet, right? Internet is the huge network, and it is collection of smaller networks. So I have just learned about a network right here. So this is the network belongs to me. For example, 192.168.100.0/24, suppose, or 10.0/24, suppose. We were having few hosts here, and maximum we can have 256 hosts, but we are talking about internet. That is fine if we know how these hosts inside a computer network communicate with each other using the switch. We only know till this point. That is it. We should also know that we should also know, understand that internet is the combination of many networks which are interconnected with each other. You never know who is controlling these network. Maybe this network belongs to Cisco, this network belongs to Airtel, this network belongs to maybe Geo. This is for my home network, suppose, which is having maybe 20-30 hosts, suppose, right? If that is the case, there is a need that we should connect these network too, so that anybody can communicate with anybody. And that is how your internet is built, right? Internet is the combination or the interconnection of so many networks. What we have discussed till yet, We have only discussed that how do computers which are inside this network can communicate with each other, right? We haven't discussed anything else. Interesting. Now, whatever network it is, if it's using the Ethernet, and the most of the network are using Ethernet, believe me, then doesn't matter if you are sitting in this network, this one, there are going to be hosts in that. There are going to be switches in that, right? So you must be pretty clear about how to host if they want to communicate inside a particular network. However, how many hosts are there? No doubt about it that they can communicate over the switch using the address resolution protocol and of course with the IP and the MAC address. If you know this, then you till now only know how two computers can communicate inside a particular network. But now in the next board, we are going to see when this host in this network, maybe this host is A, wants to communicate to some host in the other network, maybe this host is B, how these two hosts are going to be communicated, right? Because, as I mentioned, that we are using the approach of Anjali, right? If Anjali and Rahul are sitting in this room or this network, Anjali can straight away broadcast, "Hey Rahul, how are you?" And Rahul will be replying back. And we think that everybody else is obeying the rules. Nobody else is going to reply on the behalf of Mr. Rahul, right? This is not your class. That if you are not there, somebody else is doing the proxy, right? Everyone here is the law-abiding host. If Anjali is saying, "Hi Rahul, how are you?" Rahul is only replying to that, right? But do you think that suppose Rahul is not here? Maybe I do not know where Rahul is. Maybe he is here in the green network, miles away. Do you expect that Anjali will be sending this broadcast message to here to in this network because she doesn't know where Rahul is? If that is the case, Anjali should be going to each and every network and broadcasting, "Hey, Mr. Rahul, you there? Hey, Mr. Rahul, you there?" That was only fine when the ARP, we are doing ARP, that who is Mr. Rahul? I showcased you on the Fireshark, right? This is for this approach is absolutely, we know about this approach. This is not going to scale if we send this broadcast ARP message to every network. See, it is not for everybody, right? But yes, inside a particular network, we think that, yeah, it is a controlled environment. We have a little bit, whatever we have the local area network, I can send this ARP message to everybody. But try to think that if you are having your laptop, there are maybe millions of hosts on the internet, and if you want to communicate to somebody, do you think that your ARP message is going everywhere on all those 10 million hosts? No, it should not be like this. If this was the case, it would have been very inefficient method of communication, right? And this is not and this is not the way we should talk between networks. Let's see how we can talk between different network. What is the change? But as I mentioned, if you understand how you can communicate inside a particular network, which you understand now, then it is very easy to build the knowledge on top of it. You won't believe? Let's see this. Here you go. Now we are talking how two computers communicate when they are in different network. So this is network number one. Network number one has one switch, one host. Interesting. It is not the case that it is going to be only one host. There could be many. We can have another host here because we can have another host here, but we do not worry about it. Now, there is one network here which I am showcasing you in this uh, with this color, right? And the network is 192.168.10.0/24, and this host is from this network, which is 10.10. Of course, 10.10 lies in this network. That is perfectly fine. But I have another network too, which is right here, right? And this network is now 192.168 20.0/24. Now you know for sure that this is different network. And if I want to make sure that host A and host B are communicating, and if I write on host A ping host B, which is having IP address 192.168.20.20, this host immediately comes to know which host, host A. When you write this command on this host A, this immediately comes to know that I am part of a network because somebody has assigned IP address on me, which says 192.168.10.10. I have this IP address. So I know that my network range is from 10.0 to 10.255. And now I am talking to somebody who is outside my range. It means that I'm not talking inside my own network. We are pretty clear about it, right? You know this. You can do this calculation now. So does this host can, right? This host also can compute that if you write ping B, it can immediately calculate that B IP address is not part of my own subnet. I am communicating to somebody who is away from me, who is not in my own network. If I was pinging maybe this host C, suppose it is the part of your known network, then the IP address of this host should be somewhere maybe in the range of 10.0 to 10.255, maybe 10.100. If that was the case, then host A would have easily guessed that yes, not guessed, would have easily calculated that host C is part of my own network. Then whatever we have learned in the previous board, it should be like this. It is going to do the ARP will providing the MAC address. It is going to create the packet, and then the communication is going to happen. But now here we are not talking inside my own network. And if I'm not talking inside my own network, try to understand, I do not send the ARP message to the remote network, right? It is going to give me a problem, because there could be many thousand, 2,000, 5,000 networks in the world, maybe millions of network in the world. If I will be sending this ARP message to everybody, it is going to create the problem, right? Interesting. And that is why I have something in middle, which is actually doing the job of connecting these two routers. Very, very interesting, right? Sorry, these two networks, and this device, this intelligent device, is known as the router. So as you can see that we have magenta color network, we have yellow color network, and this device is actually have one hand in 192.168.10.0 network, other hand or other cable inside 192.168.20.0. So this guy knows that there are two networks. One is there, one is here, right? And who is letting this guy know? Of course, you, if you are maintaining this router, it is your responsibility to let it know, right? And first thing first, so basically, I'm just removing everything, right? I just wanted to let you know that what we are going to do here, we have two networks here, and these two hosts, now host A and host B, part of different network. So what I've done at the router level, layer, right? What I've done here is I have configured the IP address, right? So let me tell that basically I have something called interfaces here. Suppose the interfaces are 2, 0/1 and 0/2. And then I have configured network or IP address on top of it. So 0/1 is having the IP address 192.168.10.1. Can you calculate what is the network number of it? So router is taking care of the network number. It is saying 192.168.10.0/24 network is connected to me because I have the first IP address of this network or any IP address of this network. My MAC address is also C:/C:/C. So this interface is just like your PC NANIC, NIC, right? Network interface card. It is going to have two things. It is going to have IP address, which you have configured, which is 192.168.10.1, and it also has the MAC address, which is say C:/C:/C, which comes with the NIC, right? For the ease purpose, I am saying it is C:/C:/C. It is as simple as that, right? And routers, when you configure this IP address, the configuration of IP address is very, very simple, right? Dhaval will teach you how to do that. So basically the router, which you can see here, you can log in into this router. You can say, Mr. Router, I want to configure your interface 0/1. And then basically you can say interface 0/1, your IP address is this one. Which one? 192.168.10.1/24. If you write this, it is going to create this table. Okay, I have 192.168.10.1 configured on one of my interface. It means that this complete network is connected to me. Which network? 192.168.10.0/24, right? Interesting. Similarly, on 0/2 interface, you have gone and configured 192.168.20.24 network by configuring the first IP address. It is not the requirement that you should configure the first IP address on the router interface. It is not the requirement, guys. You can configure anything, but with this, router comes to know that, okay, on my right hand side interface, a network is connected, which is 192.168.20.1, and on the left hand side interface, the network is connected, which is 192.168.10.0/24. It is as simple as that. And also it writes here that this is directly connected to me. This is also directly connected to me, and you must be thinking, what is the meaning of it? Of course, these are directly connected, but in the coming classes, I will let you know that the router just not only learn these routes on the basis of directly connected interfaces, but you can tell this router that, Mr. Router, there is a route you can reach from another router. Interesting, right? We will let you know. But now here is a very simple thing. We have configured two interfaces of this router, and this router is having two different different network connected. One is this magenta network, right? Very simple. And the other one is this yellow network. Interesting. Now let's start talking, right? Now what is going to happen, guys? Host A wants to communicate to, sorry for this. Now what is happening? Host A wants to communicate to host B, and that is why you have gone to host A and you have written this statement, ping 192.168.10, not 10, 20.20, which is the IP address of host B. IP address of host A is this one, MAC address is this one, host B's IP address is this one, MAC address is this one. So of course, it is going to generate a message, the ICMP echo message. The process is going to be same. And after this, you all know for the fact that it is going to generate the IP packet. The source of the IP packet is going to be 192.168.10.10, and the destination is going to be, this is the source IP, the destination is going to be 192.168.10.20, 20.20, sorry. Why I am writing all this thing again and again? Because there is a change in the process, right? Now, this complete packets wants to go out. But first thing first, believe me, this host A, is doing so much of the calculations right now, right? What calculation is doing? First thing first, when it wants to send this IP packet outside, it is going to check what is the destination IP address. Yes, your host check what is the destination IP address. Previously, we are also doing it, right? And here the destination IP address is 20.20. You all know that this destination is not the part of my own network, right? Interesting. If this is not the part of my own network, then it means It is somewhere else. It is apart from my network. And this host knows for sure that I cannot find it inside my own network. There might be 200 or 300, 200 hosts inside my own network, but this host is not there, right? But it knows that it wants to send the packet, and it also knows that this host is not here. So what it does, then we have written some specific document for this situation, and that document is protocol, right? And that protocol is TCP/IP. Now TCP/IP says that, okay, I understand the destination is not part of your network. It means that you need to take help of the router which is connected to you, right? Maybe if this host is not a part of your own network, this host can be in some other network, and Mr. Router can handle that for you, right? And that is why inside this host, I need to define another parameter which is known as default gateway. Default gateway means that if I am so sure about that I won't be able to find the destination in my own network, then I would be sending it to somebody who can forward it on my behalf, and that somebody is gateway, and gateway is actually a router. So you can say this was my network, right? If you want to go out from this network, there must be somebody called gateway or the router, because this router might know where the destination is, right? And that is why, along with the configuration, I need to define the default gateway, which is 192.168.10.1, the IP address which is inside this network only. But now this IP address is for not for any host. This IP address for the interface, which is interface of the router, which is part of this network, which is 10.1. And generally, we define the first IP address for the router IP address. It is as simple as that. And I would like to showcase that same thing again for you, right? The network connections. If I go there, if I open Ethernet, right? And if I open change adapter options, if I open this Ethernet for you, properties, if I open TCP/IP and version 4, then you can see that I have defined the default gateway also. The meaning is, if I suppose my wife is sitting with her laptop right now, right? If I want to communicate, then that network is that is that is part of my LAN. Maybe she is getting the IP address 1.120. If I want to communicate, the process which we have learned, right? This is part of my own network. But now, suppose I want to go to google.com. Google is not sitting at my home, right? And that is why I will be sending it to this default gateway, which is 192.168.1.1, in expectation that even that I do not know about 8.8.8.8 because it is not part of my network, but somebody else can send this packet, and that somebody else is the router or the default gateway, or that router is your Wi-Fi router which you have, right? It is as simple as that. So that is why I need to mention to this host that that is perfectly fine, that if you do not want to communicate inside your host, right? But please tell me that if you want to communicate outside your host, what is the default gateway? And you have configured a router there, which is having .1 with this MAC address. Interesting, right? And here is my problem. Host A is going to see this ping message, which is encapsulated in the IP protocol, and it is seeing that the destination is 192.168.20.20, which is not the part of my own network. So where would I send it, right? Is it even worth of doing an ARP that can anybody knows who is 192.168.20.20? No, absolutely not, because this is not part of your network. ARP messages, if I say, ARP messages can flow inside your network only. Whoever is connected to the switch or switches, those messages are, because switch is only forwarding them or broadcasting them on all the ports, right? But inside this network, these ARP packets cannot go outside your messages, all right? Otherwise, it is as good as Anjali shouting to every network, you are here, or are you here? No, this is not the good way. So this host knows this destination host is not part of my own network. There is no point of asking who is 192.168.20.20. Can you tell me your MAC address? Because I know this host is not inside my network. And that is why what I need to do, I am pretty sure that this packet, whatever the packet I have generated, we are not going to find the MAC address of 20.20. So it is good that my whole sole job now is to send this packet to this router. A router will deal how to forward this packet, or the default gateway will deal. And now I know that the default gateway is at 10.1. Absolutely right. So what I'm going to do is I am going to send this IP packet, guys, whatever I have created here from here to here. This is the IP packet which is containing the ICMP message, ICMP ping. It will be right here. And you all know for the fact that at the end of the day, this IP packet is going over this wire. This wire is the Ethernet wire. And of course, the switch is only going to understand the MAC address, right? You need to put the MAC address. The source MAC address is going to be very, very simple. The source MAC address is going to be A:A:A. What should be the destination MAC address, right? So destination MAC, sorry, this is not A:A:A, this is B:B:B. So what is the destination MAC address? We do not know, right? But do you think that we are sending it, we want to send it directly to the destination MAC address? No. Where do we want to send it? We want to send it to the router because router is going to forward it, right? Interesting. But what is the router's MAC address? Because you have only specified, host has decided that the remote host or the destination is not part of my network. I want to send it to the router. Router IP address is 192.168.10.1. Because you have defined it right into there, the configuration of host A. And now host A want to send this packet to 10.1, right? But what is the MAC address corresponding to 10.1? And this is my problem, that I do not have this MAC address, right? But now I am not interested in the MAC address of the host B. I am interested in the MAC address of router, which is at 10.1. Believe me, guys, this IP packet is not going to be changed. Source IP address, destination IP address is going to be locked. This is right here, right? But the system knows, your computer knows, you cannot send this packet directly to host B. You need to take the help of the router because the host B is in some other network I do not know. And that is why you are not sure where to send this. You know that you need to send it to the router. Router's IP address, you know, the router IP address is 10.1. But what is the MAC address? Don't you think this is the same problem which you were dealing? I know the IP address of the router. I do not know the MAC address of the router. And that is why I will be doing the ARP once again, ARP, right? ARP is containing source MAC or sender MAC, sender IP, target MAC, target IP. But interestingly, the sender MAC is going to be similar, A::A::A. The destination sender IP is going to be 20. And here is the thing. The sender IP in this case is same, of course, 10.10, right? Target MAC, what should be the target MAC, guys? Target MAC, you do not know. That is what you are trying to solve. But you know that the target IP should be 192.168.10.1 because this is your default gateway. You are sending it here. You are not sending this packet to directly host B. First thing first, you need to send it to the router. Router's IP address is defined in the default gateway section of the configuration. And if that is the case, here the destination IP address is going to be the target IP address is going to be 192.168.10.1. But you must be thinking that, Mr. Vishnu, IP address throughout should not be changed, and we are not changing it. Believe me, IP address were there in this IP header. This has been locked. We are changing whatever is required in the ARP. ARP is not IP packet, right? ARP is generated by address resolution protocol. Because we know we cannot send this packet directly because this is in some other network. We want to take the help of the router. We need to first send it to the router, and we are asking now the MAC address of the router, which is C colon C colon C, and we are using address resolution protocol, right? This is my ARP packet, but again, I was holding this packet into the memory. Why? Because I couldn't complete the destination MAC address. I will be using ARP message. ARP message is generated by the ARP protocol. Now, if I need to place this ARP packet onto this guy, Ethernet interface, again, I need to put the MAC address. Source MAC address is going to be the same, which is A colon A colon A. And what I will be doing, I will be broadcasting it, right? F colon F colon F. So that this switch will send it to everybody. Switch will send it to the router also, right? This is the process which we have learned, right? Switch will send it towards the router, and router will see that the destination MAC address is F colon F colon F. I need to open it, and when it opens it, it means that it is decapsulating the outer packet, which is the layer 2 header, and then basically it will see inside what is happening in ARP. In ARP, it is going to see that the target IP address is 10.1. 192.168.10.1 is the target IP address, and this is the ARP request packet, and that is why router is generating ARP reply, because router has this IP address, because host A is asking who has 192.168.10.1. Router is saying I am 192.168.10.1, and it is replying back this address resolution protocol reply message, and that is how host knows that it needs to send this packet to C colon C colon C. This packet will be reaching right here into the router, right? Why? Because host A now can calculate, now can say that this packet is actually want to go here, right? Interesting. And in the meantime, believe me guys, this switch is creating its cam table. Why? But the first message, the ARP message, it is saying that the 0/1 interface is connected with A colon A colon A, and the reply message which is sent by the router, it is saying 0/2 is connected with C colon C colon C. So now the communication from now on, it will be. So just a change here. The whole sole point is we cannot send, right, the packet directly, because this packet is in some different network. And if that is the case, I need to send it towards the router first, right? And if I'm sending it to the router first, router should send the reply message of the ARP, right? Or basically, I will be sending this packet towards the router, and router will take it to further, right? Having said that, I am removing all the contents here, because now packet is reached to this router, right? And now let's see what router is going to do to forward this packet to the destination, which is host B, right? It is going to be again very, very interesting topic to see, right? But you all should agree with me that the packet, this IP packet now can be forwarded to here with the source MAC address of A colon A colon A, and the destination should be C colon C colon C. We have solved this puzzle of how C colon C colon C, because we have the default gateway address, and we are sending this packet to default gateway. This IP packet will be reaching here, right? This IP packet will be reaching here. And IP packet will also be having this MAC addresses. Source is A colon A colon A. Destination is going to be C colon C colon C, right? Source of this IP packet is going to be 10.10. Destination is going to be 20.20. This is my IP packet. This was my frame. When it reaches to router, router is obviously having this Ethernet interface. It will be seeing, okay, C colon C colon C, this packet is for me. It will removing the outer envelope. It is decapsulating it, and it will remain with the only IP header. And we are not changing IP at all, right? IP will be seeing that the source of this packet is 10.10. It wants to reach to the destination 20.20. It is as simple as that. Now, the router is going to see that, okay, I have received a packet who wants to go to 20.20, and I know where 20.20 is because it is directly connected network which is on 0/2 interface. It means that router wants to send this IP packet, right, which is having source address of 10.10, destination address of 20.20 over this interface. Now, because the table says that the 0/2 interface is connected with 20.0, and now this packet wants to go to 20.20. 20.20 is part of this network, and that is why I will be sending it over 0/2. It is as simple as that. But here is my problem. Once again, the problem is, if I as a router, I know that I have a connected network which is 192.168.20.0, right? And I need to send this packet to 0/2, but at the end of the day, I will be forwarding it over the Ethernet interface, and Ethernet interface is not going to let IP packet flow over it unless I put the MAC address. It means that I need to put the MAC address here, right? The source MAC and the destination MAC. Source MAC is going to be D colon D colon D. Why? Because it is coming out from the 0/2 interface. And what is the destination MAC address? I do not know. Don't you think we are getting the same problem? Through IP, I come to know that this complete packet wants to go to 20.20, but what is the MAC address corresponding to 20.20? I now know that 20.20 complete network is this yellow network. So if I send an ARP message here to calculate, to know what is the MAC address associated with 20.20, then I can easily come to know, right? Now, router is generating the ARP message, right? And router is asking the same process, but now router is asking that I am D colon D colon D, right? My IP address is 20.1. This is the sender MAC and sender IP, guys. Can you please tell me who is 20.20? Can you tell me the MAC address associated with this? Is the ARP, right? Who is going to generate the ARP? Router. Because it is absolutely sure that this IP packet wants to go to 20.20 and this 20.20 network is here. I know that 20.20 host is going to be here, exactly here, right? And that is why router is generating the ARP message. It is receiving the ARP reply back that 20.20 means B colon B colon B, and that is why router is going to put B colon B colon B here, and it will be forwarding the packet. How switch is going to learn where D colon D colon D and where B colon B colon B, you all know, we know about it, right? It learns on the basis of source MAC address and forward the packet on the basis of destination MAC address. This packet will be reaching here now, right? The packet is going to contain the IP header. And of course, in the IP, I forgot to tell you that, of course, ICMP request is there too, right? In the IP. And then basically we have this frame, which is having source as what? D colon D colon D, and destination is what? B colon B colon B. This destination MAC address is, guys, here B colon B colon B, right? When host B receives it, of course, it is going to do the decapsulation because this packet is for its MAC address. It will removing the outer covering. It will be seeing the IP packet. It will be seeing, okay, 20.20 is me only. So it will remove this. It will check the ICMP. Okay, ICMP is the request message. I need to generate the reply, and how the reply packet comes from here to here, I leave it to you. It is going to be exactly the same way. Now, the packet content, the IP packet contents are going to be reverse. Source IP is going to be what? 20.20. Destination IP is going to be what? 10.10, right? Source MAC is going to be what? You all know. Source MAC is going to be B colon B colon B, and destination is going to be your C colon C colon or D colon D colon D, right? And the process is going to be same. This router host B wants to communicate to some different network because it is going to talk to 10.10. It knows that 10.10 is not inside my network. It is in some different network. I need to do a ARP for what? 20.1, because I have specified a default gateway here too, that if you want to reach to other network, go to 20.1 first. And interestingly, it is going to do the R for 20.1. It will receive that it is D colon D colon D colon D. And if that is the case, it is sending the packet towards the router. Router will be forwarding it to this guy, right? So I have told you how the packet, let's take this pink color, will move from here to here. This is the one direction packet. Your requests are going, right? And then this guy is sending like this. So router is very, very important here. Why? Because it is connecting to network, and whatever the ARP message it receives, it router connecting two networks, right? Let me draw it here. One important thing I should tell you about a router. Suppose I have router here, and this is connecting two different networks, one interface here and one interface here, right? Very simple. If somebody is generating ARP in this, it should be inside this network. A router is not going to take ARP from this network and forwarding it to here. A router is not going to take ARP from this network and forwarding it to here. A router doesn't forward ARP from one network to another network. But as you can see, router has the capability of seeing this ARP message, generating reply, right? Router can generating the request message because it knows the host is going to be here. It can generate, can reply, but it cannot take the ARP reply into particular ARP request message from a particular network and forward it into it. It doesn't forward. It can generate though, because those are required for its functioning, right? And believe me, the statement which I have just told confuses a lot of people. It's already 1 hour. I'm not sure whether you are enjoying this or you are saying that this is absolutely, literally a torture on us. But this is how best I can explain that. If you guys have any doubt, any question on this, you are more than welcome to ask the questions. Anybody? Mr. Dhaval? Okay, just tell me you are not sleeping. Just raise your hands. Okay, there are some hand raises. It means that you are awake. At least some of you are. This is perfect. Mr. Dhaval or Mr. Rohit, do we have any questions? Okay.
Yeah, Vishnu.
Perfect. Do we have any question, Dhaval?
There was one from Rachit. If broadcasting to large number of devices is efficient, then in case of a very large network as well, will not this approach be inefficient as well?
Absolutely, this is going to be. For example, the question here is, Rachit is asking that, okay, if you have 10, 12 network, that is fine, 10 to host. What if we have a big network of 512 hosts, suppose, right? And everybody is doing their work. And suppose one guy says, I want to communicate to this guy or somebody else, and everybody is receiving this ARP. Doesn't it going to be an inefficient approach? Believe me, Rachit, that is why we are going to subdivide this network. And that is where the VLANs or virtual LANs are coming into picture. Do not worry about it. But it is very, very interesting that you are thinking this way, because anything, whatever the concept we are going to learn now on, we understand the basic networking. Believe me, we understand how to compute a stock when are in the same network, how to compute a stock when there are different network. Whatever we are going to learn from now on, We will be solving the problems, whatever comes, right? For example, we will be trying to make this system efficient enough. You now the question, whatever you are, whatever I'm receiving, are the question on the efficiency of the system. But nobody is doubting that at least we can forward the packet, right? So this was the problem when I started, that we have computer A, we have computer B, and these two guys wants to communicate. These guys want to send the packets. I think we all convinced that using TCP/IP model, till now I am agree with you that you do not have the complete understanding of it, and that is why you are saying the system is inefficient, right? But till this point, at least you all should be agree with me that the system can forward the message from host A to B. Doesn't matter if they are close by or very far away, right? Do not worry, Rachit. We will be solving this inefficiency problem later on when we are doing the switching. And this is the problem. Yes, broadcasting is a problem. You are right. Anybody else? Anyone else? Question?
There is another query from Rachit only.
Mm-hmm.
So he's saying that when sending the ICMP response to the other network,
Mm-hmm.
can't the host B refer to the DLL header to get the MAC address of the default gateway?
Yes,
Rather
actually,
than doing
yes,
ARP again?
yes. They don't. It doesn't need to do the ARP again. It can cache this. It can cache this reply, basically into the ARP cache. You are right. I am wrong. Absolutely wrong here. It doesn't need to do ARP again. Okay. But again, you are right now looking into the efficiency of the system, which is good. Now you all should agree. Okay, give me the hand raise if you all agree that TCP/IP model, right? Whatever approach it used to send the message, it is you got that approach. Also, I agree with you that we do not know everything about it. That's why you are saying that it's inefficient. I will prove you that system is quite efficient over the period of next 4 or 5 days. Believe me. But I want a hand raise that if you get something out of this board and previous board. Anybody? Okay, so shall I presume whoever is not raising the hand, they have some doubt? There are so many, believe me. Oh, now they are also raising the hand. This is good. This is absolutely fantastic. Perfect, perfect. And I could see that 60 to 70% just raised the hand. And believe me, if you get 60 to 70% out of this board, you are actually ahead of many, many network engineers, even the professionals which are having experience of 2 to 3 years also, or 4 to 6 years also, right? But just a request, you will be forgetting it within no time. If you just repeat this recording, I know it is a long recording, but if you can just make some notes while watching this video recording once again, it is going to be with you forever. Okay? And believe me, when I was reading these concepts, right, I will tell you one important thing, my experience, right? Around 12, 13 years back, when I was preparing for my CCN exam, right, it was very, very difficult, right, to because all the informations are there. How ARP works, what is the default gateway, what is IP addressing, everything was there, right? But what is something that is combining all of the pieces together? I was having literally hard time, right? Maybe I was not using the correct book, the correct resources, and videos were not that good at that point of time. So believe me, whatever I just told you, those are from multiple books. I am combining the knowledge of multiple books to you, right? So you get the clearer picture. You just need to spend some time. The approach should be, if you can just give whatever. I think we have learned 13 hours last week. One session was only for 1 hour, and remaining sessions are, I think, for 2.5 to 3 hours. If you can devote 13 hours over the weekend, I'm not sure why do you want to do that, but the what what we can say, the results are that going to be really, really awesome. These 13 hours are going to be our basics, because from the next week onwards, whatever we are going to learn, that is just we are making this system more efficient. We will be introducing some more concept of switching like VLANs, trunking, spanning tree protocol. Believe me, that is going to make your communication inside the same network more efficient. That is it. We will be learning routing also, specifically OSPF, that will be making the network learning approach of this router more efficient. But the initial thing, how communication happens, from rest, from whatever we are going to read in in this course, it is going to be just increasing the efficiency of the system, and that system name is TCP/IP. Right? I haven't talked about OSI model, and one more thing I want to set the clear expectations. We are not going to cover each and every aspect of CCNA, because that requires maybe more than 80 hours to complete, right? Or 60 hours to complete. So I encourage you that if I have taught you the TCP/IP model, right? If you have any doubt about OSI model, please have a look at that, right? Now OSI model is also going to make more sense to you. Just few tips which I would like to give you, because at the end of the day, the whole sole purpose of this training is that you should understand the fundamentals. I want to make your fundamentals really strong so that you can face the customer. And the second point is that you pass your exam also, right? Keep reading. Last topic of the day, right? I have showcased here that these two uh, networks, the yellow network and the magenta network, in the same network, sorry, connected to the same router. But here is my last board, and believe me, there is nothing new in this board. But now what is happening here is, now we can see multiple routers, right? The duty of the router is to connect multiple networks. And let's see, here we have Anjali, which is in India right now. Here she is, right? And we have Rahul also. Here, Rahul has moved to US, suppose, and he is inside some network in the United States of America. Maybe this is the network somewhere in the Australia, and everybody is connected over the networks. Suppose this network is, say, 192.168.10.0/24 network. This Anjali's IP address is 10.10, and Rahul's IP address, and suppose Rahul network is 192.168.200.10, sorry, 0/24, and the Rahul IP address is suppose 20, right? Suppose. And now these two guys wants to communicate. As simple as that, right? What is going to happen? Anjali is going to generate the IP packet, and this IP packet is going to be, maybe they are pinging from India to, this IP packet is going to be having the source address of 10.10, the destination address of 200.20, and of course the ICMP message is there, right? And now what is going to happen? This is your IP packet from here to here. It will be encapsulated. Also, color coding is wrong, guys. Previously, I was using some other things. So maybe the source MAC address is suppose here A:\A:\A. So here is the source address A:\A:\A, right? From here to here is your IP packet. From here to here, your L2 header. And now you notice one thing. This MAC address is, right? What should be the destination MAC address? You all know the destination MAC address cannot be the MAC address of Rahul, and the reason is Rahul is in somewhere else, right? USA. So Anjali is asking, who can help me to send this packet towards Rahul? And this router is replying back, okay, Anjali, I can help you. I am your default gateway. You must know my IP address, and the IP address here is maybe 10.1, and the MAC address here is maybe say C:\C:\C. So we will be putting C:\C:\C here, and this packet will be reaching here. When this packet reaches here, this guy will be eliminating this guys, right? the layer 2 header, it will see the packet wants to reach to 200.20, and I'm not sure how, but router 1 knows about it, right? That if you want to send the packet to 192.168.200.0/10, and of course, this IP packet, the destination IP packet is into this range because 200.20 is part of this range, /24, then send it towards router R2. Maybe here is the IP address of the router R2. Maybe this IP address is supposed 2.2.2.2, right? And this is again the network, guys. So whatever you are seeing the lines here, this is again the IP addresses, right? Or the network. This is one network. This is another network, right? And you will be configuring the IP addresses here. So suppose I have configured the IP address here 2.2.2.2. Here the IP address is 2.2.2.1. Both are, and /24 I have put here. Suppose. So it is saying that to reach 192.168.200.0/20, you need to go via R2, and the R2's IP address is 2.2.2.2, right? How router 1 is actually getting this information, this we will be learning in dynamic routings, right? So which we are going to cover in this session, which is OSPF protocol, right? But for now, R1 knows about that where is 200.0. If you want to go towards 200.0, send the packets toward R2, right? That is it. And send the IP packet. So I will be showcasing the IP packet like this. This was my IP packet. And now I am going to put the MAC addresses. What should be the MAC addresses here, guys? The MAC address, because we are talking about this network now, the source MAC address is of this interface, this one, right? Which maybe say R1, this interface address, source address is say uh, uh, D:D:D, suppose, right? So source is going to be D:D:D. What is the destination? The destination is going to be say here, which might be X:X:X, right? So the packet will be reaching here. R2 will be checking that, okay, the destination is for X.X. This is my address. It will be removing it, and it is getting the IP address. What this IP address contains? Source and destination IP addresses are not changing. What is changing? There is a change in the source MAC and destination MAC. At every hop, here it was something else. In this network, it was something else, right? Similarly, if we talk about R2, this IP packet reaches here. IP packet destination address is going to be 200.20, right? Where the 220, maybe R2 also knows about it, that to reach 200.0/24 network, 192.168.200.0 network, you need to go via R3. We need to give IP addressing here. Maybe this IP address is 3.3.3.2. This IP address is 3.3.3.3, maybe part of the same network. This is your entire one network, right? And now it is saying to send this packet, you need to go via R3, which is 3.3.3.3. It is as simple as that, right? And now this IP packet, when it reaches here, it wants to go to 200, and it is matching this statement. The IP packet will be reaching here, right? What should be the source MAC and destination MAC of this packet? You all know the source MAC is going to be, let me put this way, source MAC is going to be this interface, destination MAC is going to be this interface, right? Interesting. Again, the source MAC, suppose this is Y:Y:Y, and this is P:P:P. I'm just giving any name, right? This is going to be Y:Y:Y, destination is P:P:P, and this reaches to our router R3. Again, the source MAC and destination MAC is changing. And by the way, guys, how these guys are going to know about what is the MAC address along 3.3.3.3? Again, routers are doing ARP here. Routers are doing ARP here, right? The packet, IP packet will be reaching here now, this time, right? R4. Again, when it reaches here, the IP packet, it is going to be having the source IP address of whatever, right? 10.10, the destination IP address of 200.20. It means that R4 will be checking, oh, this network is directly connected to me again, but who is 200.20? Now there is a query, the ARP query or ARP request. Who is 200.20? ARP is replied, and the packet will be forwarding to this. Oh, this is how the packet is going hop by hop. Destination and source IP addresses are here, which is the responsibility of network layer. But to make sure that this packet reach from R3 to R4 or R2 to R3, there is a data link layer, right? Which is going to put the MAC addresses. And that is why we need to IP's responsibility is to just book source and destination IP, which is never ever changing during the complete communication. Data link layer is responsibility is to send the packet to nearby router or nearby host, and that is why MAC addresses are changing at each hop. It is as simple as that. So try to understand, if I say a packet comes to router or frame comes to router, what does it contain? It contains the L2 header, which contains the MAC addresses, right? M1 and M2. And it also contains the IP address, sorry, IP header, and the data, maybe ping. It contains the IP addresses, right? It means that when the packet reaches to this router, router understand that it is having layer 2. It can read layer 2. It can also read once it comes out from the layer 2. Router 2 can see the where this packet wants to go. So router actually understand layer 2 as well as layer 3. And of course, bits, whatever is coming, they are going to understand. And that is why we call routers the layer 3 device. Why? Because layer 3 is the topmost layer which is understood by them, and layer 3 we have IP addresses. It also understands layer 2, which means the MAC addresses. It also understand it. You can connect the copper cable. It also understands the layer. If I say router is a L3 device, it means that it can understand L3, L2, and L1. It is as simple as that. But if on the contrary, if I talk about the switch, right? On the contrary, if I talk about the switch, as I mentioned, although the switch receives the IP packet, and on top of it, there is a L2 header, which is the source MAC and destination MAC, switch does not see even what is there in the IP packet, right? No, it doesn't understand IP. It understands only layer 2. And of course, you can connect the copper cable. It means that switch can understand maximum layer 2. And that is why it is the layer 2 device. Somebody say firewall is a layer 7 device. It means that we are referring, for example, TCP/IP doesn't have layer 7, right? So if we are saying layer 7, it means that we are talking about OSI model. It means that firewall understands L7 and all the layers below it, L6, L5, L4, L3, L2, and L1. And by the way, topmost 3 layers of the OSI model represent one layer, which is application layer here. And that is it. Remaining 4 are same. Having said that, although we would like to explain today regarding some of the practical aspects, but I don't think that we are in the situation of doing that. So Dhaval, I will be sitting with you from the Monday onwards, that let's do some practicals. Whatever we have learned, let's show these guys, and of course, everybody, right? Guys and girls, everybody, that how exactly these packets are flowing in over the real devices. Okay. If you guys have any slightest of doubt in your mind, please do ask the question. Anybody? Dhaval, do we have any question?
Yeah, Vishnu, there's a question from Monica. So the question is, if we connect multiple routers to a switch, then what would be the configuration of other routers? So probably FHRP can be a good example for that.
Yeah. So this is good. People are literally running faster. So if we have a switch here, and if we connect 2 routers here, one router is this one, and one router is this one. And I think the question is that if we have a few hosts here, right, where should I will be going, right? From R1 or towards R, which should be my default gateway. So there are a lot of things involved here, Monica. we are actually just starting. So if you consider the full networking like this, so we have just learned maybe only this much, right? The entire ocean still. But whatever we have learned till now, this is the strong base. Believe me, I can explain Dhaval, Rohit can explain you right now what is going to happen, but this is not going to make sense now. Let's make, means maybe if we can tell CCNA will be covered till this point of this complete ocean, right? And very basic things about it, right? So once we are done with that, then we will be talking about it. But yes, as mentioned by Rohit, the first hop redundancy protocols are going to come into picture, like VRRP is the standard protocol, and HSRP, which is the hot standby routing protocol, come into picture. Although we can see two routers here, but one is going to be active and the other will be remaining the standby state, right? And your traffic will be going from here to here all the time. Once it goes down, we are going to move the packet. But yes, I am pretty impressed to see now that the questions are not in terms of basic understanding how the packet is going to be processed. The questions are now towards more towards the efficiency of the system, right? What if this router goes down, then we have another one, and that's why we use first hop redundancy protocol. But do not worry about it. The names, whatever we are going to read, these are going to be simple, but these are making my networks more efficient. This is nothing which is fundamental, right? So first, let's complete the fundamentals, and then definitely we are going to talk about how we can make this complete system more efficient. Believe me, people have already worked on it. There are so many cool protocols, so many rules which are going to make this TCP/IP system more efficient. Having said that, Mr. Rohit or Dhaval, do we have any other question?
No, Vishnu. So today we are not going to walk them through the lab.
I doubt, Dhaval, because it's already 3 hours, right? And I don't think that we should bombard them with much more information. Okay.
No worries. Sure.
So guys, for your information, I would like to tell you one thing, that this time the training is different. Previously, it used to be 8 hours per day, right? We are just 3 hours, and there are so many concepts you need to learn in a day, right? So we are doing a change in this training from, because you do not have any clue about what we have changed. So we have reduced the training from 8 hours to 3 hours, right? So I would say, please be attentive. Try to listen these recordings, right? If we are sparing the 5 hours for you, because I understand that human brain cannot process this much of new information, right? Please be with us in this change. Otherwise, if this experiment is not going to be successful, we will be returning into that mode again, right? We will be bombarding 5 continuous days of 8 hours of this information. It is going to be very, very difficult for the. So please, in your remaining time, just try to, I'm just, the expectation is just be curious that how the things are working. That is it. We are done with the starting 12 to 13 hours over this week. Just listen them. Start making your own notes, right? I can give you the notes, my notes, but believe me, notes should be made by the one who is actually referring them later, right? So your notes should be personalized to you, right? See these videos over the weekend. If time permits you, please make some notes. And if you face any doubt, any problem, ask in Monday's session. And in Mondays, from the Mondays, we will be introducing the practical. Dhaval, Punish, or anybody else will be guiding you to that. Having said that, if we do not have any question, I can see that there is a hand raise from Tharun.
Yeah, Vishnu. Yeah, I was just going to.
Okay. Tharun, do you? Okay, that hand is now down.
So Vishnu, just wanted to reiterate on the packet tracer, right? As we already have taken a introductory session, if they have time, like today, if they can install and just have a walk through it. I mean, they can refer the recordings.
Okay.
right? And they can install it, and probably on Monday when we do the lab,
Okay.
some of them can also do it in parallel, so they will have the concepts clarity.
Perfect. So guys, there is a requirement from our side. When you come back on Monday, I need everybody should install the packet tracer on your laptop. Doesn't matter if it's a Mac laptop, Windows laptop, whatever it is, just go register yourself with Cisco Academy. Download the packet tracer. I think Dhaval has informed you. I don't want to see anybody who does not have packet tracer, because that is going to be very, very important, right? Dhaval, any other information, other message you want to deliver?
No, that's all, Vishnu. So at least, I mean, if they have it on their machine, so they can relate it in a better way
Perfect.
rather than just
I can
watching it and understanding.
Perfect. Okay, thank you so much. I literally want hand raised that if you like today's session. How many of you like today's session? Okay. Okay, this is good. I can say that 3 hours and these people are saying that, okay, we are liking the session. This is good. Perfect. Perfect.
In that case, Vishnu, we can extend the hours. Maybe we can add up 1 or 2 more hours if they are really liking it.
Yes, yeah. Okay. How many of you says that let's add 2 more hours for today, Friday? Just raise your hands or lower your hands down. Oh my God. Only four are saying, only three? No, 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 no. Even those are raising the, okay, lowering the hand. Perfect, perfect. Enjoy your weekend, enjoy your Friday. Have fun, guys. And thanks for being a one. Harshit, you want to run more for next 2 hours? Okay, that hands is off. Enjoy your Friday, right? Have a blast and see you on Monday. Thanks for being a
So
wonderful
Harshit
audience.
actually
Yeah.
was waiting for the lab session.
Oh, okay. Okay.
Wait.
Okay. See you guys. Bye. And thank you so much, Prashant. Thank you so much, Dhaval and Rohit. You are awesome. Bye for now.
Thank you.